Hello there and welcome back to the Sleep Science. You let the room settle around you. The screen's glow dimmed to something you could almost cup in your hands, and outside the window the night wraps everything in the same understated velvet. It's practiced for billions of years. The stars feel closer tonight, like they've pressed their faces to the glass to watch you back. We're heading out to meet a stray visitor slipping into the solar system from the dark between suns, and yes, it's lovely, it's strange, and it has the sort of energy that makes astronomers whisper and refresh their plots at 3 a.m. Gentle warning, you probably won't survive this wave of coziness, because we're dialed to that sleepy frequency where even cosmic mysteries feel like warm tea. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me where you're watching from and what time it is for you. I love seeing the map fill with our little constellation of night owls. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge to the proverbial edge of the solar system, wearing that half smile you save for late night documentaries and snacks you swore you wouldn't open. In the deep black ahead, 3I/ATLAS arrives, a visitor with a passport stamped by no star you can name. It's not loud, it doesn't need to be. Its path is the whisper of a straight line sliced into the sun's curved dominion, a line that screams, by its very calmness, I do not belong to your little family of ellipses. At first you try to catalogue what you see. The object glints with a colour that refuses to commit, somewhere between old copper and storm-bruised ice. Spectra murmur about complex organics baked by time and radiation, but the readings come with caveats and asterisks, the kind you learn to treat like those tiny warning labels on microwavable mugs. Harmless, probably, unless you do something imaginative. A wake of dust trails behind, not the broad, glamorous plume of a showboat comet, but a thin seam like a loose thread on a well-travelled coat. You reach out with your attention and feel it fray. A sliver separates, then another. Fragmentation, the murmurs say, as if the word itself might coax the pieces back together. You watch them peel off in featherweight detachments, not exploding, just letting go. The fragments drift as if practicing a slow ballet nobody invited them to. It's hard not to anthropomorphize rocks. You promise not to, and then you do it anyway. To be fair, you anthropomorphize your coffee maker when it refuses to brew, so 3I/ATLAS is in good company. For a heartbeat, you think of other strangers. You remember Oumuamua, the first interstellar object we spotted back in 2017, when pan-stars caught that hurtling sliver and everyone collectively forgot how to breathe. A very mainstream historical fact taps you on the shoulder. Before 1995, astronomers had never confirmed a planet around another sun-like star. Then 51 Pegasi b arrived, and the universe turned from a polite theory into a crowded neighbourhood. Same energy here. Once you see one visitor, your brain unlearns the myth of solitude. The road has always been there. You just finally noticed the headlights. You pull closer to the new traveller, and your eyelids feel heavier, the way they do on trains when the landscape slips into a repeating rhythm. 3I/ATLAS carries pitted scars across its surface, tiny craters like dimples and sunward faces that glow a dull, reluctant amber. Every rotation, a faint plume. The gas isn't noisy. It's the quiet of an old library book when you turn a page. Dust motes, not drama. Somewhere a researcher mutters about volatile depletion and thermal fracturing. Somewhere else someone compares it to a baked-out comet core, an asteroid masquerading in a comet's tattered shawl. You nod, half amused, because space does love a costume party. If there's a cosmic dress code, it's come as you are or as a small mystery. A quirky tidbit floats up from the silt of your memory. Ancient Egyptians sometimes mix crocodile dung into sunscreen and cosmetics, because humanity's relationship with probably fine goes way back. You file it away, already sensing you'll need a callback when things get even stranger. The point isn't the sunscreen, it's the pattern, our reflex to explain the unfamiliar with whatever we've got lying around. Tonight, 3I/ATLAS is the unfamiliar. The room hums softly, the fan becomes your white noise star. The data stream trickles past your fingers like cool water. Light curves suggest slight irregularities, little dips that imply outgassing jets nudging the trajectory by whispers. The orbit, hyperbolic, the eccentricity, delightfully greater than 1, like it's bragging about extra credit. You can almost hear celestial mechanics clearing its throat, reminding you that an interstellar visitor is a straight-line tourist through our curved theme park, here for a photo, gone after the ride. And yet something in you wants to keep watching, because the fragments aren't just peeling off, they seem to shed with a rhythm, not clockwork, not yet. But a pulse your body notices before your mind does, the way you sense bass through a wall before you recognise the song. You tilt your head and a memory unspools, Halley's Comet, the most famous periodic show, recorded by Chinese astronomers more than 2,000 years ago. Medieval Europeans painted it with golden tails above crowded towns. Historians still argue whether a 12th century monk's description was an aurora or a comet seen through fog, but the habit is old. We watch the sky and write poetry or panic, occasionally both before breakfast. You feel very small and very included. Another fragment loosens, drifting like a breadcrumb you pretend not to notice while absolutely noticing. You consider how fragile materials become after 1 million years of cosmic weathering, then 1 billion. Radiation peels bonds apart, micrometeorites tick the surface like metronomes, temperature swings bully the lattice. If a thing has been wandering the galactic suburbs long enough, it's basically a cracker in a wind tunnel. Note to self, do not pack crackers for interstellar hiking. As you follow the crumbs, you catch the soft voice of skepticism. Maybe nothing here is special. Maybe this is a garden variety, if rare, interstellar shard losing a bit of mass, and your human pattern engine loves to sketch constellations into any scatter of dots. Your shoulders relax. The nice thing about a sleepy investigation is that no one expects you to solve the universe before the outro. You just have to watch closely and notice what changes. The instruments hum, imagined but convincingly, and the spectrum grows teeth in the infrared. There's a hint of methanol maybe, faint organics, dust grains that look older than your entire species by an embarrassing factor. The object's albedo resolves into a depressed whisper, darker than average, as if it has spent too long tanning without atmosphere. Somewhere in the analytic noise there's a suggestion of isotopic ratios that don't match the median of our comets, not by a mile, but the error bars wave back like polite lifeguards. You feel safe to be curious. You let your breath slow with the fan. Another mainstream touchstone settles beside you. When Galileo turned his telescope to the heavens in 1609, he saw that the Milky Way was a smear of countless stars, not a milky fog. Seeing better doesn't just sharpen the scene, it changes the cast list. Tonight's cast includes 3 I/ATLAS, a handful of fragile side characters flaking off in dignified silence, and you, the observer in a chair that counts as a spacecraft if you squint. Comedy beat. You consider filing a travel expense report for mind-left solar system, snacks consumed en route. You trace the hyperbola, fingertip drifting across an imaginary ephemeris, and notice how the path slices past the sun like a practiced fencer. The perihelion distance is generous. No death dive, no dramatic sublimation flare, just a careful thread through the inner garden. That thread matters, you think, without knowing why. It tickles the part of you that loves diagrams and underlines grocery lists with different coloured pens. A weird pattern is in the title of tonight's journey, and your bones are politely starting to agree. On the edge of your awareness, the night outside your window shifts. A car sighs past. Somewhere, a neighbour coughs, and then the quiet swallows it again. In that softened hush, you lean closer to the mental telescope and let yourself imagine that the fragments are not entirely random. You don't commit. You don't need to. You just hold the possibility like a small bird, warm, fragile, chirping in a language of granules and glare. If the cosmos is trying to tell you something, it's doing it the way the best storytellers do, slowly, with breadcrumbs, and at an hour when your guard is down. And in that gentle mood, you allow a last playful thought. If there is a space, TSA 3 I/TLAS has definitely checked declaring snacks, because those fragments are practically samples. You smile. You add a new page to your mental notebook. The visitor keeps moving, the fan keeps purring, and you float alongside, ready to learn what it wants to teach you by simply being what it is. You drift with the fragments still in view, their slow pirouette fading behind as another memory surfaces. one that begins in 2017 with a sliver of rock tumbling through a patch of sky above Hawaii. Oumuamua, the first interstellar object ever caught red-handed visiting our sun, flashes across your imagination like a half-remembered headline. You remember the speculation, the artist's renderings, the memes calling it a cosmic baguette. Scientists swore they could see it spin end over end every 7 hours, like a baton flung by an invisible hand. That's the moment you realise when humanity went from, maybe there are wanderers out there, to, oh, they actually swing by for tea. You slide closer to that ghost, tracing the parallels. Like 3I/ATLAS, Oumuamua came from nowhere, its trajectory too straight, its velocity too rude for the sun to have birthed it. It was all speed and no nostalgia. Even now, researchers replay its brief cameo like film critics watching the same 3 seconds in slow motion. The mainstream historical fact everyone agrees on. Oumuamua was the first confirmed interstellar object detected passing through our solar system. That tiny milestone cracked open centuries of complacent astronomy. Before that, textbooks treated our cosmic address as isolated, like a house with a fence. Afterward, the fence turned out to be decorative. The telescope data still whispers in your ear. Oumuamua didn't have a tail, no outgassing plume, no cometary fuzz, just a bare rock, or possibly metallic slab, shrugging off the sun's heat with suspicious composure. The absence of a visible tail was almost louder than a display would have been. Historians still argue whether the odd acceleration it showed as it left the sun was due to sublimating ice, radiation pressure, or something more exotic. It's the kind of debate that keeps graduate students caffeinated and Reddit threads eternal. You picture 3I/ATLAS in that same cosmic context, the next guest at the interstellar reunion. Oumuamua was the introvert who left before the after-party. 2I/Borisov, discovered in 2019, was the friendly comet who arrived trailing glitter and actual gas jets. Now 3I/ATLAS drifts in, half breaking apart, half performing. 3 is a pattern, your brain whispers, even if statistics call it coincidence. You've been told never to infer a rule from 3 data points, but your sleepy imagination winks and breaks that rule on purpose. The observatories stretch across Earth like a network of eyes. Mauna Kea, Cerro Paranal, La Palma, Palomar. You imagine them all blinking in rhythm, trying to catch this new intruder's face before dawn wipes the stars away. Every image adds a puzzle piece to an orbit that's as unsolar as it gets. Hyperbolic. Negative semi-major axis. Words that mean no going home, no capture, just a flyby on cosmic scales. Yet something in the residuals hints that these visitors, Oumuamua, Borisov, ATLAS, might have brushed near the same broad galactic stream before veering our way. You picture a galactic current, slow and ancient, threading through local interstellar space. Maybe a loose filament of gas and dust, maybe an invisible gravitational contour carved by the Milky Way's arms. A quirky tidbit bubbles up. There's an old speculative idea called the interstellar tube, proposed by a fringe researcher in the 1980s, suggesting that debris could drift along magnetic corridors between stars like fallen leaves caught in street gutters. Mainstream science never bought it, but tonight, as 3I/ATLAS glides within your inner eye, the notion doesn't seem entirely laughable. You can almost feel the drag of that invisible current against your fingertips. You drift past Oumuamua's memory, toward the present where 3I/ATLAS flares faintly. You notice how astronomers still replay old data from the earlier visitor, cross-referencing its light curves against ATLAS's breaking shell. One fragment's albedo matches Oumuamua's, reddish, non-reflective, like dried clay left too long in starlight. Another fragment's spectrum shows a whisper of cyanide compounds. The room's fan hums a low commentary. Maybe everything that travels long enough through interstellar space ends up steeped in the same cosmic marinade. A gentle aside, you imagine trying to explain this to someone centuries ago. Rocks from other stars are paying us a visit. Galileo might have squinted, Kepler might have demanded the orbital math, and Newton would have immediately invented new calculus just to describe the trajectory before anyone else could. It's comforting, really, that curiosity ages well. The characters change, but the impulse stays. Now the story drifts from data to feeling. You picture the astronomers waiting for dawn after a long observing night, bleary-eyed and grinning, comparing notes over stale coffee. Someone jokes that if the universe keeps tossing interstellar objects our way, soon they'll have to make a new category: visitor objects, handle with wonder. Another researcher sketches the orbits on a tablet, overlaying Oumuamua, Borisov, and Atlas. The lines crisscross like spider silk, faintly echoing one another. Coincidence, maybe, or the start of something patterned. You float beside the drawing. The human brain loves to draw lines through stars, naming them constellations. It can't resist connecting dots. That's both our gift and our curse. You think of the old Greek astronomers who turned random scatterings into myths. Orion's belt was never meant to hold up anyone's trousers, but our minds tied it anyway. Now, we're doing the same on a galactic scale. The thought makes you smile, then yawn. Through the haze of drowsy analysis, a deeper question hums. What else travels the spaces between stars? Microscopic dust grains, sure. Rogue planets, definitely. But what about seeds of life? Ice-locked bacteria, the occasional fragment carrying amino acids across light years. The panspermia debate flickers like an old candle. Historians still argue whether the idea's modern revival is science or poetic wish fulfillment. Either way, it keeps the imagination company during long nights. A flash of humour stirs. If microbes ever hitched a ride on Oumuamua, they must be terribly disoriented by now, like tourists realising the bus doesn't stop anywhere they recognise. You chuckle softly, then feel the weight of the cosmic scale return. Each visitor reminds you that our solar system is not sealed. It's porous, open to the traffic of the galaxy. We're the apartment with the light on at 2 a.m, and the neighbours occasionally knock. Somewhere, telescopes in Chile and Japan exchange data packets. Algorithms look for repeating vectors, small deviations that hint at a shared origin. Could these objects come from the same dying star system, ejected together eons ago? Or are they strays from unrelated corners, merely sharing a statistical fluke of direction? Historians still argue whether coincidences in space mean kinship or chaos. For now, you just listen to the silence between radio bursts. Oumuamua fades into darkness, trailing questions instead of gas. 3I/ATLAS remains, its fragments reflecting dimly against the sun's thinning light. You note how each visitor has rewritten a little of astronomy's script. First surprise, then classification, then philosophical whiplash. The categories, comet, asteroid, meteor, start to feel like kindergarten labels pasted on PhD mysteries. The fan in your room sighs, the narrative glides. You feel that familiar warmth of curiosity that sneaks in right before sleep. The comforting thought that something is out there, travelling, indifferent yet beautiful, reminding you how temporary every orbit really is. If Oumuamua was the first knock, Borisov the second, then Atlas is the third, and in stories the third knock is never just coincidence. You float deeper into the dark, still trailing the glittering crumbs of 3I/ATLAS as they spread like a quiet snowfall across the void. It's time to stop pretending you know what this thing is, and start admitting how little anyone does. Comet or not comet, you murmur to yourself, the way someone might mutter cat or raccoon at a shadow on the porch. Astronomers have asked the same question for months now, each camp waving their preferred equation like a flag. You watch from your comfortable distance halfway between spectator and dreamer as the labels begin to blur. To the untrained eye, it looks comet-like, a pale haze curling away from the nucleus, a faint tail that behaves when it wants to and sulks when it doesn't. But the brightness curve doesn't match a normal comet's predictable tantrums. You can almost hear the collective scratching of heads across observatories. It's not bright enough for the mass they think it has, not volatile enough for the sunlight it's getting, not anything enough, really. The universe loves a paradox, and you perversely find that comforting. A mainstream historical fact drifts by, easy to grab. In 1997, Comet Hale-Bopp became one of the brightest comets in centuries, visible to the naked eye for a record 18 months. It was textbook, predictable coma, reliable tail, no arguments about what it was. People held backyard parties under its glow, snapping disposable camera photos that came back half exposed and overjoyed. Compared to that celestial extrovert, 3I/ATLAS feels like the shy cousin who arrives late to dinner and refuses to say where they've been. Your gaze narrows on its nucleus. The light it throws back has a flicker, a subtle modulation that hints at irregular rotation. Astronomers call it a tumbling body. which sounds poetic until you realize it means rolling helplessly like a dropped potato. Still, there's a rhythm to it. 3 rotations forward, 1 tiny jerk sideways, as though something inside resists the spin. You can't help anthropomorphizing again. Perhaps the object is holding secrets tightly, unwilling to let them be flung off by centrifugal honesty. A quirky tidbit arrives like a whisper from the archives. Back in 1858, one amateur observer swore he saw a comet with a gap in its tail, and newspapers ran with it. Turns out he'd looked through a dirty eyepiece smeared with candle soot. Humans have always mistaken smudges for miracles, and sometimes miracles for smudges. You think of that every time 3I/ATLAS's data graph blips, wondering which kind of smudge this is. The debate burns on. Some argue it's a fragment from a shattered comet ejected from another system. Others propose it's an asteroid covered in dark, carbon-rich gunk, faking a cometary plume only when sunlight pries open microscopic cracks. Historians still argue whether the line between comet and asteroid ever truly existed, or if it was just a convenient filing cabinet for human sanity. Out here, definitions melt faster than ice in vacuum. You glide closer, adjusting your imaginary focus. The fragments surrounding the nucleus resemble a slow-moving family, each piece faintly reflective, loosely bound by nothing but shared trajectory. One looks elongated, another almost spherical, a third oddly plate-like. You remember the jokes about Oumuamua being a solar sail, an alien probe hiding in plain sight. The scientific papers politely called that non-gravitational acceleration inconsistent with known mechanisms. Everyone else called it weird. You exhale softly. Space doesn't need aliens to be interesting. Physics alone does a good impression of them. You picture the researchers hunched over spectra, searching for signatures, hydroxyl bands, cyanogen emission, maybe faint sodium lines. The data refuses to commit. Ambiguous, reads the summary. A single word that can launch 100 theories. You smile sleepily. It's practically the universe's favourite mood. A soft cosmic wind, solar particles trickling outward, nudges the dust around Atlas into a faint tail that stretches millions of kilometres, thinner than smoke, shimmering like spider silk in sunlight. The tail shifts shape daily, like it can't make up its mind which way to flow. Your half-dreaming thoughts compare it to the way you shift in bed trying to find the cool side of the pillow. Somewhere back on Earth, an astronomer refreshes an orbital simulation for the 100th time. Each fragment has its own micro-orbit now, all diverging slowly. You imagine her sighing into her coffee, naming each particle after breakfast foods just to stay sane. Pancake fragment continues nominal course. Waffle fragment is being annoying. It's both comforting and absurd that the same human impulse governing spreadsheets also reaches into the stars. As you follow the swarm, a question creeps in. Why do all 3 interstellar visitors, Oumuamua, Borisov, and ATLAS, display some form of breakage or activity? Borisov outgassed itself into dust. Oumuamua spun itself like a baton. Atlas is literally coming apart. Maybe that's just what happens when alien rocks wander too close to our sun's warmth. A kind of stellar welcome party that none of them survive. Or maybe, your drowsy imagination suggests, it's something in the way they're made. You picture their surfaces like old ceramic, cracked from endless freeze-thaw cycles in interstellar space, each fracture a memory of a different star. A faint chime of déjà vu lingers. You think of Hale-Bopp again, its 2 bright tails, one dust, one ionized gas. Those tails pointed directly away from the sun, elegant and obedient. Atlas's tail, on the other hand, kinks halfway through its length, as if pulled by 2 competing winds. Magnetic fields, maybe. Or, because you're in that half-dream state now, some internal magnetic anomaly flexing within the fragments themselves. You'll file that under weird, revisit later. The longer you watch, the more hypnotic it becomes. A fragment passes through a patch of solar wind turbulence, flickers, and then disappears from sight. Lost, or simply too faint. Another fragment emerges unexpectedly on the opposite side. Your inner scientist tries to track mass balance. Your inner storyteller just whispers, it came back changed. You think of the way comets were once treated as omens. In 1066, the Bayeux Tapestry showed Halley's comet blazing above King Harold, interpreted as a sign of doom or victory, depending on whose side you were on. Historians still argue whether people saw it as divine punishment or celestial encouragement, but either way it got better press coverage than most medieval events. You grin. Comets have always been good PR for chaos. Atlas's fragments keep orbiting their vanishing centre. If you overlay their paths, you'd get something like a slowly unfurling flower, each petal trailing a thread of dust. The pattern is random enough to satisfy skeptics, symmetrical enough to tempt believers. You linger on the site, feeling the soft tug of curiosity at the edge of sleep. Maybe this fragmentation isn't an ending. Maybe it's the first hint that something larger, some pattern you can't yet name, is unfolding right in front of you. And then, just as your thoughts begin to dissolve into dream, one last image flashes in your mind. A single fragment spinning faster than the rest, brightening for a heartbeat, then fading. A pulse, a beat, a hint of rhythm. You smile, whisper "noted," and let yourself drift. You wake, or maybe just drift, to the soft hum of pattern recognition unfolding across the cosmic canvas. Around 3I/ATLAS, data points multiply like fireflies caught in a jar, each tiny orbit blinking at its own tempo. You hover beside the researchers' simulations as if watching fish in an aquarium made of math. It should all look random, rocks flung by gravity's caprice, but your eyes keep catching faint repetitions, lines that cross and recross in improbable harmony. A weird pattern indeed. Astronomers begin mapping the swarm. They plot each fragment's path, and when the trails overlap, delicate lattices appear, filigrees of motion curling around nothing. At first, they dismiss it as coincidence, the same way you might dismiss the shape of a cloud that looks a bit too much like your favourite snack. But then more fragments fall into place. The geometry persists, echoing faint spirals that resemble orbital resonances, yet not quite. Some paths loop back near identical points before fanning outward again, as though drawn by invisible handwriting. A mainstream historical fact floats through your half-dreaming thoughts. Johannes Kepler, in the early 1600s, discovered that planets move in ellipses, not perfect circles, and that their orbital speeds vary predictably with distance from the Sun. His laws tamed the sky's apparent chaos into elegant math. You imagine him now, squinting at these Atlas orbits, frowning in delight and mild irritation, because this pattern refuses to fit his neat equations. Even 4 centuries later, the universe still likes to surprise the overconfident. You lean closer. One researcher at Mauna Kea overlays the tracks of ATLAS fragments with trajectories of previously catalogued micrometeoroids. The match isn't perfect, but there's a rhythm in the inclination angles, each cluster tilted at roughly the same degree, as if they'd entered the solar system through a single cosmic doorway. Others spot faintly repeating perihelion points, those closest approaches to the Sun, forming a lopsided polygon when connected. You can't help whispering, "That can't be random," even though you know the universe thrives on coincidence. A quirky tidbit bubbles up. The French mathematician Henri Poincaré once proved that 3 or more bodies interacting gravitationally can produce chaos so deep it's practically poetry. He called it the 3-body problem, though after tonight you suspect it should have been the infinite patience problem. The Atlas fragments, despite numbering only a few dozen, behave like a Poincaréan ballet, predictable for a few steps, then tumbling into graceful unpredictability. It's chaos that flirts with order, never committing either way. The pattern hunters arrive, some with PhDs, others with YouTube channels and way too much spare time. They start layering the orbital maps on social media, discovering that if you exaggerate the scaling just right, the lines form a spiral reminiscent of the golden ratio. Skeptics roll their eyes. Dreamers declare it proof of alien geometry. Historians still argue whether seeing order in randomness is a mark of genius or of boredom. You, somewhere between sleepy and curious, find the symmetry soothing. You picture a computer room buzzing under fluorescent light. The machines hum as they crunch through millions of simulations, gravitational perturbations, solar wind effects, radiation pressure. One algorithm flags a recurring anomaly. A subset of fragments periodically cluster every 33 days, then disperse again. The number feels arbitrary, yet pleasingly round in human terms. You smirk. Maybe it's the universe's sense of humour, sinking its debris like an off-brand calendar reminder. Your imagination wanders to the people behind the data. There's a postdoc in Madrid who sketches orbital plots on napkins because they calm her nerves. An amateur astronomer in New Zealand aligns his backyard telescope by intuition and sheer stubbornness. Somewhere in between, you hover, spectator, dreamer, participant in a shared cosmic riddle. You zoom out, overlay Oumuamua's inbound vector, then Borisov's, then Atlas's. A faint corridor emerges, not quite parallel but aligned within a few degrees. A cosmic traffic lane running through our solar neighbourhood. Statistically, maybe meaningless. Poetically, delicious. You imagine invisible highways threading the galaxy, gravitational slipstreams carved by tides of dark matter or ancient star clusters. The scientist in you mutters confirmation bias, while the dreamer leans in closer, whispering, "But what if?" For a moment, the data visualization looks like a blooming flower, each orbit a petal, the sun its heart. The petals pulse with simulated motion, breathing gently on the screen. You chuckle. Maybe it's not a pattern at all, just beauty sneaking in through math. Then another program overlays velocity vectors, and the humour fades to wonder. The fragments' approach speeds differ only slightly, within a narrow window far tighter than random ejection should allow. The odds of that alignment by chance are microscopic. Somewhere, a conference Zoom call erupts into argument. One researcher insists it's mere selection bias. We only notice patterns once we're looking for them. Another counters that such precision implies a shared origin. The moderator sighs audibly, refills their mug, and reminds everyone that astronomy is, at heart, a fancy way of staring and hoping. You grin at the thought. Science is just organised curiosity with better snacks. A faint analogy takes root. The way murmuration flocks of starlings move, swirling without collision, each bird guided by invisible neighbourly cues. Maybe Atlas's fragments perform a similar dance, their motions subtly coupled by outgassing plumes, magnetic fields, or the lingering memory of how they once held together. You like that idea, that even in disintegration, there's coordination, a final act of togetherness before silence. Your eyelids grow heavier, your breathing sinking with the imagined rhythm of those fragments. Every orbit, every flash of data point feels like a heartbeat. You realise that patterns, real or imagined, are how the human brain sings itself to sleep. Long before telescopes, ancient watchers turned star scatter into constellations, stories, gods. Now we do it with orbital charts and Monte Carlo simulations. Same melody, new instruments. The last image you hold before the darkness deepens is that digital flower of orbits, petals overlapping, breathing light across the black. It reminds you that the line between order and illusion is a soft one, and maybe tonight, that's exactly where you want to rest. You're still suspended there, half inside the data, half inside your own drifting mind, watching the petals of those orbits fold and unfold. It's the next morning, or maybe the same night stretched thin, and a new wave of analysts has arrived determined to wrestle meaning from the noise. They call them statistical ghosts, patterns that seem alive only because the data insists on playing tricks. You hover beside them, invisible but attentive, as screens fill with heat maps and probability clouds that look suspiciously like modern art. The first truth to remember, one that every bleary-eyed scientist repeats like a prayer, is that randomness often pretends to have a plan. The cosmos is a master illusionist, scattering fragments just so, coaxing human minds into joining the dots. You recall a mainstream historical fact. In the 18th century, the mathematician Thomas Bayes proposed his famous theorem, the groundwork of modern probability. He didn't know it then, but he'd handed future generations the tool that would both save and torment data analysts forever. Tonight, his ghost sits politely in the corner, whispering, "Check your priors." You glance at the current priors, models expecting uniform distribution of interstellar objects, no preferred direction, no rhythm. Then you look at the fresh plots of 3I/ATLAS fragments, and the others arriving in its wake. They clump. Not neatly, but definitely more than chance predicts. Someone mutters about selection bias again. Someone else swears softly, citing Monte Carlo results that refuse to flatten. The term cluster illusion gets tossed around like confetti at a skeptical parade. You drift closer, eavesdropping on minds both brilliant and sleep-deprived. A quirky tidbit breaks the tension. Apparently the human brain is so desperate for order that even pigeons trained to peck for food will invent rituals if rewards appear at random. One flaps its wings twice before pecking, convinced that's the lucky combo. You smile. Humans and pigeons aren't so different. Both are pattern finders first, philosophers second. Here we are, flapping our mental wings at cosmic breadcrumbs. The analysts deploy statistical artillery, bootstrapping Gaussian kernel estimations, clustering coefficients that would make Bayes blush. Each method gives a slightly different answer, and none agree completely. Historians still argue whether such disagreements are signs of scientific vitality or evidence that we simply enjoy arguing in the name of progress. Either way, caffeine sales remain strong. You drift around one particular simulation running on a supercomputer in Maryland. The model generates fake interstellar arrivals, millions of them, just to see how often randomness might mimic the pattern we're seeing. Most of the time, the fake data looks like cosmic static, but once in a while, an eerily similar cluster appears. False positives birthed by chance. The program flags these as phantom alignments. You can almost hear the cosmos chuckling. And yet, despite all the talk of illusions, the observers can't shake a subtle unease. The clustering isn't uniform, it's temporal. Objects aren't just arriving from similar directions, they're arriving close together in time, like cosmic buses ignoring the schedule until they all show up at once. You could dismiss 2 arrivals as coincidence, 3 as curiosity, but half a dozen within a few years. Even the most hardened statistician begins to fidget. You feel that same quiet itch under your skin. Somewhere between logic and wonder lives a thin crack where imagination breathes. You peek through it. Suppose these ghosts aren't accidents. Suppose there's an underlying rhythm, something buried in the galactic background that gently nudges material toward our system every few decades. A wave, perhaps, of gravitational influence from a passing molecular cloud. Not impossible, not proven, just possible enough to keep the night interesting. Back on Earth, a press release drafts itself in someone's inbox. No evidence for organised swarm around 3I/ATLAS, scientists say. You can almost predict the comments section before it exists. Half relief, half suspicion. Humans love denial as much as they love mystery. It keeps both sides of the brain employed. You zoom back into the simulation, following one particular data thread. A tiny dot representing a modelled fragment that happens to mirror ATLAS's actual path. When the program resets, this artificial particle drifts into resonance with a virtual Jupiter, completing a slow oscillation that mimics reality a little too well. Coincidence, the algorithm insists. But coincidences have their own gravity. A memory surfaces. In 1986, Halley's comet returned to Earth's skies after 76 years, and thousands of people camped out to see it. Many were disappointed. It appeared fainter than expected. Yet astronomers celebrated the predictability, the proof that celestial mechanics worked. Now, watching 3I/ATLAS and its kin defy that neat predictability, you can't decide which is more thrilling, the precision of known physics or the flirtation with its edges. Historians still argue whether science progresses by tidy equations or by restless nights staring at statistical ghosts. A researcher somewhere jokes that if this turns out to be an alien breadcrumb trail, the first thing humanity will do is run a significance test to prove it's not. The room laughs. You laugh too. Humour is the only defence against the cosmic abyss. The debate winds down as dawn bleeds across observatories. Screens dim, coffee cups empty. The consensus, for now, is that the clusters might be artifacts of observational bias, telescopes seeing what they're most tuned to detect. You respect that caution. It's the scientific equivalent of counting your change twice. Still, as you drift back toward the imagined orbit of 3I/ATLAS, you can't unsee the symmetry that first caught your eye. The lines linger, faint but insistent, like music you can't forget. You whisper to yourself, half lullaby, half confession. Sometimes ghosts are just echoes waiting for translation. The pattern refuses to fade, even after all the statistical ghosts have been politely exorcised. You hang there in the twilight of data and doubt, watching as 1, then 2, then 5 new dots blink onto the solar system's edge. Fresh discoveries. Each one has that same telltale signature, an incoming velocity too high to be native, an eccentricity that laughs at the number 1. They're not from around here. You tilt your head, sleep heavy and curious. The growing family of interstellar wanderers is officially large enough to need a reunion planner. Astronomers scramble to name them: 4I/IRIS, 5I/Nemesis, 6I/Silk Road. The names start to sound like indie bands on a cosmic tour. Telescopes around the world pivot in unison, like spotlights searching for celebrities. One mainstream historical fact rises through the buzz. When Clyde Tombaugh discovered Pluto in 1930, he used a blink comparator, 2 photos of the same patch of sky flicked back and forth, to catch that faint dot shifting against the stars. It was patient, analog magic. Now we have automated survey arrays sweeping the heavens every night, running digital versions of the same trick millions of times faster. Still, the principle hasn't changed. Stare long enough, and motion betrays the visitor. You drift over a virtual map showing their trajectories. The lines overlap faintly, converging near the same galactic quadrant, as if the newcomers all stepped through the same unseen door. A chill of coincidence, or choreography. You feel the scientist's skepticism and the storyteller's grin colliding in your chest. If the galaxy is a dance floor, this is the moment you realize everyone else already knows the steps. Fragments of 3I/ATLAS still drift, fading into the black, but the new objects arrive fresher, less eroded, less tired. Their surfaces reflect just enough sunlight to tease out faint colors: dusty red, coal grey, a glimmering olive hue that one instrument swears is a trick of calibration and another insists is real. A quirky tidbit pops into your sleepy brain. In the 1970s, scientists once mistook a chunk of human-made space debris, part of an old rocket stage, for a natural asteroid, officially cataloguing it before sheepishly realizing it was one of ours. The universe, it seems, isn't the only thing capable of sending mysterious visitors. The new interstellar bodies begin to show subtle similarities. Each one enters at a shallow angle relative to the ecliptic plane, not plunging in dramatically, but coasting, like seasoned travelers avoiding turbulence. You imagine them carrying invisible luggage, isotopic ratios, molecular secrets, perhaps the cosmic equivalent of sand still stuck to shoes from a distant shore. Observatories buzz with comparisons. Are they siblings? Fragments of some ancient stellar collision that flung debris across light years? Or are we simply in the path of a migrating herd of orphaned rocks? Historians still argue whether the Milky Way's spiral arms act as cosmic highways or chaotic soups of debris. If there are lanes, we might just have wandered into one. In one control room, the walls glow with orbital plots, arcs bending toward the sun like the fingers of a reaching hand. An intern notices something odd. The average inclination of the new objects is nearly identical to ATLAS's, differing by less than half a degree. That's small, too small. A hush spreads. The lead researcher jokes that the solar system has joined a galactic traffic circle, and no one bothered to signal. Everyone laughs, but it's the nervous kind of laugh, the sort that happens right before you admit you might be seeing history's edges bend. You let your mind wander to the poetic possibility that somewhere, far away, an ancient star exploded, scattering the rocky children of its planets outward in a grand, slow-motion diaspora. Over millions of years, those shards drifted apart, stretched thin by time, until they now rain across our region of space in measured intervals. You picture them as messages without senders, letters carried by the wind so long that the ink has faded. Back in reality, the new discoveries come faster. Automated alerts ping researchers' phones like cosmic push notifications. The headlines start to pile up. 4th interstellar object discovered in 2 years. Another hyperbolic intruder detected. You can almost hear the collective astonishment turning into logistical exhaustion. A sleep-deprived astronomer tweets, "At this rate, we'll need traffic control." You chuckle softly. Even the galaxy can't escape bureaucracy. Through your drowsy haze, you wonder what binds these wanderers beyond coincidence. Is it the galactic tide? Those slow gravitational ripples caused by passing molecular clouds or distant stars? Or is it something subtler? A pattern of motion etched into the background fabric. The universe's quiet heartbeat pushing matter through space like waves across a pond. You recall an older debate, whether space between stars is truly empty or laced with faint magnetic filaments guiding dust and rock like invisible rails. The interstellar highway theory was fringe, filed under probably nonsense, yet here you are, watching trajectories that seem to glide along shared lanes. If it is nonsense, it's a beautifully consistent kind. In your mind's eye, the solar system starts to look porous, open at the edges like gossamer. Sunlight spreads across the new arrivals, and you catch flashes. Greenish flares from one, spectral hums from another. Instruments on passing spacecraft detect faint traces of complex hydrocarbons, even ammonia ice, the same ingredients found in comets, but older, colder, more worn. These are relics, you realize, fossils of alien chemistry. A tiny thrill runs through you. Maybe these are our galactic ancestors. Maybe every planetary system sends out emissaries like spores, drifting until they seed new worlds. You can almost hear a cosmic gardener humming somewhere beyond the stars. You're aware, of course, that your romanticism outruns the data, but that's fine. Science always needs a dreamer pacing outside the lab. Someone in the control room mutters about a strange periodicity. The average time between these arrivals seems to shrink. 2 years, then 18 months, then 14. If plotted, it curves like a heartbeat accelerating. Another coincidence, perhaps. But tonight, coincidences are growing suspiciously rhythmic. You drift away from the chatter and picture it all from above. The sun at the centre, planets tracing lazy spirals, and beyond them, these new interstellar lines cutting through like silver threads. Together they form something, an emergent geometry too large to see at once. The pattern may be illusion or revelation, but either way it feels alive. For now, you simply float there, eyes half closed, as the growing family of visitors glides closer, their faint glows pulsing like distant campfires. You can't tell whether the solar system is being visited, examined, or merely brushed by the galaxy's restless current. Either way, you feel lucky to be awake, or at least awake enough, to witness the first few notes of whatever symphony this will become. You slide outward again, away from the inner glow of the sun, and into the dim frontier where those visitors glide. The newly discovered family stretches across the sky in faint lines, each one a slanted brushstroke on the canvas of space. From this vantage point, their shared orientation becomes undeniable. They're all arriving from the same distant quadrant, a region of the galaxy we've barely charted, angled just below the galactic plane. Astronomers start whispering about a corridor, though no one wants to say the phrase out loud yet. It sounds too conspiratorial, too science fiction. You, however, have no such restraint. You can't help smiling. The galaxy might have highways after all. The term spreads quietly in the community, the Galactic Highway. Someone sketches it on a whiteboard, a soft curved trajectory linking the interstellar objects' inbound paths. At first it's a joke, a coffee-fueled nickname. Within weeks, it's an official hypothesis in progress. People begin tracing gravitational contours, modelling how local interstellar clouds and magnetic fields might act like slow conveyor belts, channeling debris toward our system. It's messy work, a blend of math, intuition, and sleepless optimism. A mainstream historical fact drifts to mind as you watch. In the 19th century, Urbain Le Verrier predicted the existence of Neptune by noticing subtle anomalies in Uranus's orbit. He couldn't see Neptune directly, he inferred it through math and motion. The same trick might be playing out now, except this time, what's unseen isn't a planet, but a vast current of space. You imagine Le Verrier grinning in spectral approval. You drift through the imagined corridor. In your mind's eye, it's not empty. Threads of ionized gas shimmer like aurorae, stretched across light years. Charged particles trace delicate ribbons that could, under the right conditions, guide tiny masses the way a river carries leaves. The sun's motion through the galaxy means we cross new regions all the time, some thick with dust, others nearly sterile. Maybe we've just sailed into one of the denser streams. A quirky tidbit surfaces from memory. Back in the early 2000s, researchers discovered microscopic interstellar dust grains embedded in Antarctic ice. They fell like invisible rain, carrying isotopic ratios that didn't match anything born of our sun. Even Earth, it turns out, has been sipping from galactic rivers for ages. You chuckle softly. We've been bathing in cosmic runoff without realizing it. The community splits into camps. One argues that the highway is real, a gravitational corridor sculpted by the local bubble's magnetic field lines. Another insists it's a fluke, the astronomical equivalent of seeing faces in clouds. Historians still argue whether such divisions are healthy or tragic, but you find them oddly comforting. Every mystery worth chasing breeds disagreement first, faith second, and funding proposals third, you hover beside a virtual simulation, three-dimensional, glowing in blues and golds. Lines representing Atlas, Borisov, and the newer intruders all bend inward along the same invisible curve, then flare outward after slingshotting past the sun. The pattern looks almost biological, like veins under translucent skin. Coincidence, says the skeptic in your ear. Coordination, whispers the dreamer on the other side. You stay between them, listening to both. As you watch, one researcher overlays the sun's galactic trajectory on the same map. The two curves, the incoming highway and our star's own motion, almost cross at a right angle. You imagine the solar system plunging through a galactic stream, each interstellar visitor like a raindrop hitting a moving car windshield. The metaphor clicks. We're not being visited, they're stationary, and we're driving through their storm. Outside your window, the room hums softly, the fan providing your local solar wind. The rhythm of its blades syncs with the imagined drift of these objects. You catch yourself swaying slightly, hypnotized by the thought that the galaxy might possess weather, slow, immense, and unseen. Maybe the pattern isn't a mystery to solve, but a forecast to interpret. Astronomers begin to speculate about the contents of the corridor. Could it be a byproduct of a long-gone supernova, the remnants of a shattered system now stretching across parsecs? Or maybe it's the spine of a defunct stellar nursery, a leftover filament where gravity once birthed stars. Each theory comes with spreadsheets and caveats, each punctuated by that sweet phrase, "Further observations required." Meanwhile, more dots appear, smaller ones barely visible, each following the same approach vector. The count rises past a dozen. It's starting to look less like coincidence and more like migration. The media catches wind, headlines blooming with cosmic drama. You imagine late-night talk show hosts making jokes about space tourists, and for once, they're not entirely wrong. A sudden flare from one of the newcomers jolts your attention. Spectrometers catch a spike in cyanide compounds, the same signature once detected in comets of our own system. That's strange. The odds of unrelated interstellar objects sharing identical chemistry are slim. Maybe they formed from the same parent disk billions of years ago, siblings scattered across the galaxy. The family metaphor fits again. You can almost hear a lullaby in the hum of your fan, the universe humming to its wandering children. You picture them all converging, a slow caravan of ancient bodies threading through space, silent but synchronized. Somewhere deep inside, you feel an odd tenderness toward these frozen travelers. They've been moving for longer than our planet has existed, bearing witness to eras we can't imagine, and now, by pure accident or design, they've chosen our neighborhood to pass through. If this is a galactic highway, then 3I/ATLAS was merely the first car you noticed. The rest of the traffic is only now emerging from the fog. You smile at the thought, then let your mind loosen its grip on reason. Maybe there's even a rhythm to it, a cosmic tempo setting the pace for arrivals, a slow heartbeat felt through gravity itself. You yawn. The glow of the imaginary corridor dims, the solar system keeps drifting, the newcomers keep arriving, and somewhere beyond human reach, the galaxy continues its quiet conversation in patterns we're only just beginning to overhear. You glide deeper along the imagined highway, your consciousness stretched thin across the vastness like a soap film catching starlight. Behind you trail the smaller visitors, 3I/ATLAS, Borisov, the newer ones, all fading into faint streaks of memory. Ahead lies speculation. The debate that began as playful murmuring now swells into something more daring, whispered first in conference hallways and late-night Zoom calls, then typed cautiously into the discussion sections of papers. What if these aren't accidents of gravity at all? What if someone, or something, shaped this corridor long ago? You're not supposed to say it out loud. Astronomers are allergic to the word intentional. It's the conversational equivalent of stepping on bubble wrap in a library. But the symmetry of those trajectories, the eerie uniformity of chemical signatures, each fresh discovery adds a syllable to a word no one wants to pronounce. You hover beside the conversation, listening, equal parts skeptic and dreamer. A mainstream historical fact steadies you. In 1960, Frank Drake launched Project Ozma, the first modern search for extraterrestrial intelligence, pointing a radio dish toward Tau Ceti. He heard nothing conclusive, unless you count the persistent echo of curiosity. That moment marked the birth of SETI, and the quiet acknowledgement that we were finally listening, not just looking. Now, decades later, the same spirit stirs again, except this time the question isn't, are they talking, but did they leave something behind? Speculative papers multiply like spring weeds. Some propose natural causes, a galactic filament of debris from a long-dead star guided by magnetic lines. Others, bolder, suggest that if a civilization wanted to seed the galaxy with self-replicating probes, they might release them along stable gravitational corridors. The argument is half math, half mythology. You feel the weight of both. A quirky tidbit bubbles up from the depths of your sleepy trivia vault. In 1974, the Arecibo Observatory beamed a binary-coded message toward the globular cluster M13, depicting human DNA, our solar system, and a friendly stick figure. Historians still argue whether it was a genuine attempt at communication or a publicity stunt to prove we could. Either way, it meant that for one fleeting moment, Earth spoke with intention. Maybe 3I/ATLAS, and its kin are what intention looks like from the other side. You imagine drifting alongside one of the fragments, pitted, ancient, rotating in silent time. Could it hide machinery beneath layers of cosmic varnish? Not necessarily blinking lights and antennae, just structure, ordered lattices where none should exist, patterns too deliberate to be the outcome of random chemistry. Your rational side clears its throat. No evidence yet. The dreamer smiles back. Yet is the most generous word in science. Across the world, radio telescopes pivot toward the swarm. The data comes back mostly silent, punctuated by the usual hiss of cosmic background. But once in a while, a narrow spike appears, brief, faint, gone before analysis can pin it down. Engineers blame interference, satellites, even refrigerator compressors at nearby facilities. Still, a few can't help wondering, if someone did send out interstellar messengers, wouldn't they be built to whisper, not shout? Conversations in the scientific community take on that peculiar tension between thrill and embarrassment. A planetary scientist jokes that humanity has two responses to mystery: classify it, or panic about it. The rest of the table laughs nervously. You can almost hear the click of keystrokes as someone adds a line to a grant proposal. Further investigation into potential non-natural origin scenarios. The universe loves loopholes, and funding forms are no exception. You tilt your imaginary viewpoint back toward the galactic plane. If these are messengers, where did they come from? The direction points roughly toward the constellation Lyra, same region that hosts the famous Vega. Bright, hot, and only 25 light-years away. Historians still argue whether Contact, that old Carl Sagan novel, chose Vega by coincidence or by poetic instinct. Either way, the overlap tickles your sense of cosmic humour. You whisper, "Hey Vega, did you send us mail?" In quieter hours, researchers allow themselves to wonder, what would a civilization billions of years older than ours use as a message carrier? Light is fleeting, fragile. Objects, though, solid matter, can endure. A probe disguised as debris could drift unnoticed, patient as geology. It could record, watch, maybe even plant the occasional seed of curiosity. Perhaps the act of noticing the pattern is the message. You laugh softly. That's the sort of recursive elegance the universe seems to enjoy. You picture an ancient workshop orbiting a long-extinct star. Engineers, organic, mechanical, or something in between, design small bodies meant to survive eons. They don't send them toward anyone in particular, just release them like dandelion fluff. Let chance deliver them, they say. After 1 billion years, one of those seeds happens to pass through our yard. We look up, blink, and call it 3I/ATLAS. Your rational side frowns again. The evidence remains painfully slim. A few aligned orbits, similar velocities, common chemistry. All could be natural. Yet your eyelids grow heavy with the gentle thrill of maybe. Even skepticism can sound like a lullaby when whispered by stars. Before sleep claims you entirely, you replay the facts. 3 confirmed interstellar visitors, several more candidates, all arriving from roughly the same direction. A galactic corridor that might be real, might be illusion. And within that uncertainty, the ancient temptation to imagine meaning. Humans once read gods into thunder. Now we read intention into trajectories. Maybe progress is just upgrading our metaphors. You breathe out slowly. The hum of your fan becomes the background radiation of the cosmos. If the highway was carved deliberately, then every fragment gliding through it is a relic of purpose. If it's natural, it's still no less miraculous. Either way, the night feels vast and kind. You smile at the thought that somewhere out there, a civilization could be looking back, tracing our tiny outbound probes, and wondering if we were the ones who seeded the pattern. You let that possibility rock you toward rest. Half science, half story, entirely wonder. You drift down the galactic corridor like a leaf in slow water, chasing the faint debris tails of 3I/ATLAS until they dissolve into glittering dust. For a while, there's only silence. Then, like a whisper in static, a new fascination begins to hum. The dust itself seems to be speaking, or at least that's how the scientists describe it, half joking, half serious. The dust is gossiping. They're referring to microparticles, so small they slip through sensors like grains of smoke, each one carrying a chemical signature stranger than the last. These are the dust trail whispers, faint as breath but full of stories. As spacecraft instruments sweep through the edges of Atlas's debris field, they find isotopic fingerprints that don't match anything native to our system. Ratios of carbon and nitrogen lean toward values expected in stars older than the Sun by billions of years. You let that sink in. These grains predate the solar system, older than Earth's crust, older even than the dust that built the planets. You're holding history so ancient it makes fossils look newborn. A mainstream historical fact keeps you grounded. In 1947, the Allende meteorite fell over Chihuahua, Mexico, scattering fragments that revealed some of the oldest minerals ever found. Calcium-aluminum inclusions dating back to the solar system's infancy. Scientists call it the Rosetta Stone of planet formation. You smile, because now we've found something even older. Cosmic relics that remember not just our beginning, but someone else's. The analysis continues. Some particles are laced with exotic isotopes, deuterium ratios too high, oxygen anomalies that look like fingerprints from foreign chemistry. You imagine those atoms as tiny tourists carrying passports stamped by long-dead suns. When solar radiation hits them, they fluoresce faintly, releasing photons that instruments capture like notes in a song. And buried in those notes, oh, there's rhythm again. Not a pattern of words, not communication, but repetition. Peaks and troughs at evenly spaced intervals. The scientists label it periodic emission resonance. You prefer to call it heartbeat. You lean closer as though you could actually hear it. The waveform rises and falls like breathing. It could be natural, a product of spin and sunlight scattering, or it could be, as one speculative researcher suggests, structured variation. The phrase alone is enough to spark 1,000 conspiracy threads. Historians still argue whether the modern age is defined more by discovery or by how quickly we meme it. A quirky tidbit emerges from an older archive. In 1956, scientists accidentally discovered microwave emissions from the center of the Milky Way while testing a radar system. They'd found the galaxy's heartbeat without meaning to. You wonder if history is repeating itself, if we've stumbled onto another accidental revelation, hidden in the dust of a passing rock. You drift closer to an imagined spacecraft brushing through ATLAS's wake. The instruments hum softly, analyzing the incoming particles. One speck vaporizes on impact, releasing gas that smells faintly, if you could smell vacuum of ammonia and burnt sugar. Complex organics, life's handwriting written by physics rather than biology. You think of amino acids forming spontaneously in the void, frozen in starlight until chance delivers them to some fertile world. Maybe Earth was one of those worlds once seeded by dust like this. The idea of panspermia feels less poetic, more logistical, a galactic mail system with no return address. The data keeps coming. Grains collected by simulated probes show layering, thin shells alternating between silicates and hydrocarbons, like geological growth rings. That shouldn't happen in the interstellar medium, where collisions are rare and chaotic. Something about it feels manufactured. The official term is non-equilibrium layering, but the subtext is clear. It's weird. You picture an astronomer at 3 a.m., staring at the spectra, whispering, "Okay, but what is this thing?" It might be easy to dismiss as coincidence if the dust trails weren't also behaving oddly. They twist around each other, forming corkscrew patterns visible in polarized light. The geometry repeats in other interstellar fragments, like a signature flourish. Your rational mind says magnetic interaction. Your sleepy one murmurs handwriting. Either way, the effect is mesmerizing. News filters down to the public in simplified form. Alien chemistry discovered in comet dust. The scientists cringe, the bloggers cheer. You, half asleep at your desk, feel that delicious pull between skepticism and wonder. We've been here before. When the ALH 84001 Martian meteorite was found in Antarctica in 1984, NASA thought it contained fossilized microbes. The world held its breath. Decades later, debate still simmers. Mineral or microbe, life or artifact? Historians still argue whether that moment marked the dawn of astrobiology or the golden age of wishful thinking. You run a mental finger through the data again. The dust from 3I/ATLAS hums faintly with ionized energy. Each grain spins just so, oriented by the galactic magnetic field. Together, they form faint threads trailing behind the object like musical notation. You imagine reading it, note by note. Hydrogen, carbon, nitrogen, oxygen. 4 letters repeating in endless variation, the cosmic alphabet. Maybe that's all the message ever was, chemistry composing itself. For a moment, your thoughts drift toward the edges of imagination. What if these interstellar objects are messages, but not in any language we'd recognize? Not beeps or patterns, but material poems, fragments whose atomic arrangements encode lessons about the physics of their home systems. A civilization advanced enough to think in isotopes could write whole libraries into dust. You picture them sending out clouds instead of probes, trusting entropy to deliver knowledge through beauty. You shake your head, smiling. It's a lovely idea, but so far the evidence fits simpler stories. The isotopic ratios could come from ancient red giants, their winds dusting the galaxy long before our sun was born. The layering might form naturally in the vacuum's slow collisions. The resonance pattern could be rotation, not rhythm. Science always gives you multiple endings to choose from. Tonight you pick the most romantic one, because you're allowed. Outside your window, a breeze nudges the curtains. You realize you've been breathing in time with the graphs scrolling across your imagination. The dust, the rhythm, your pulse, it all syncs for a heartbeat, and you feel very small, very connected. Whether these whispers come from aliens, stars, or chaos doesn't matter right now. What matters is that the universe has been talking all along. We just finally built instruments sensitive enough to overhear its softest sighs. You exhale and the dust trail drifts onward, vanishing into silence. The silence after the dust settles doesn't last long. You feel it, an almost imperceptible tension threading through the laboratories, the observatories, even the quiet online message boards where astronomers gather like insomniac monks. Their models, so careful and mathematical, are beginning to wobble. Something about these new objects, 3I/ATLAS, the others following in its wake, simply won't behave. The phrase starts to circulate, the models are breaking. It's not an accusation, just a quiet admission that the equations we trust to describe gravity and motion are suddenly wearing cracks like tired porcelain. You imagine a planetarium dome filled with glowing orbits, lines looping neatly, until one segment snaps out of place, just enough to make everyone lean forward. The computers keep recalculating, each iteration insisting it's correct while reality shakes its head. A mainstream historical fact drifts through your mind to offer context. Back in 1915, when Einstein introduced general relativity, it rewrote how scientists understood gravity. His predictions about Mercury's orbit, how its perihelion precessed slightly faster than Newton's laws could explain, were confirmed, proving that even small discrepancies can herald revolutions. Maybe that's what's happening now. Maybe these anomalies are the universe's polite way of saying, upgrade required. At first, the errors seem small. The new interstellar bodies decelerate slightly less than predicted as they approach the sun, or accelerate just a fraction faster as they leave. Each deviation is tiny, barely measurable, but consistent. If it were just one object, fine. Cosmic dust pressure maybe, or hidden outgassing. But when multiple visitors show the same defiance, the equation starts sweating. Simulations run overnight, filling hard drives with terabytes of disappointment. Students check their code for bugs. Professors check the students for bugs. Nothing explains it. We're missing something, one says, the way a doctor might say, this fever shouldn't exist. A quirky tidbit slips from memory. In the 1980s, NASA's Pioneer 10 and 11 probes began to drift slightly off course, decelerating more than expected as they coasted out of the solar system. The Pioneer anomaly, they called it. For years, theories bloomed: dark matter drag, modified gravity, even whispers of extraterrestrial interference. Eventually, it turned out to be mundane: heat from the spacecraft's power source radiating asymmetrically, gently nudging it backward. Yet for a while, those few millimeters per second of mystery made physicists giddy. You wonder whether the same thing is happening again, except this time, the explanation refuses to show its face. In the control rooms, tension thickens. Orbit-fitting algorithms spit out confidence intervals that look like Jackson Pollock paintings. Someone suggests solar wind variability. Someone else invokes the Yarkovsky effect, tiny thrusts caused by uneven heating and re-radiation of sunlight. But none of it fits perfectly. The deviations persist even when all known forces are accounted for. You hover above one simulation like a ghostly consultant. The model shows the sun at the center, lines of incoming interstellar bodies sweeping through. As each passes, its trajectory bends, not by the clean curve gravity demands, but by something slightly skewed, as if space itself hiccuped. The programmers increase precision, adjust constants, curse gently. Still off. Historians still argue whether anomalies are science's greatest curse or its secret fuel. Without Mercury's precession, no relativity. Without Uranus's wobble, no Neptune. Maybe 3I/ATLAS, and its siblings are hinting at another layer of the cosmos, one hidden beneath our elegant assumptions. You consider the possibility that space isn't as smooth as we imagine, but textured, like fabric stretched over unseen patterns. The idea makes you sleepy in the best way. At conferences, the tone shifts from curiosity to controlled panic. Papers begin to use cautious phrasing, non-gravitational acceleration inconsistent with standard models. You grin. It's the academic equivalent of, we have no idea, but it's awesome. Some researchers suspect invisible mass, tiny clumps of dark matter passing nearby. Others propose that interstellar objects might carry magnetic fields of their own, interacting subtly with the heliosphere. A few, braver still, suggest they're following something unseen, an external influence guiding them, not with force, but with resonance. You imagine the universe like a vast pond. The solar system is just a leaf floating on its surface, and these visitors are waves, passing through, bending the leaf's path. The pond itself isn't still, it's humming, vibrating at frequencies too low for us to detect. Maybe our physics models assume still water when the reality is music. Your inner skeptic reminds you that extraordinary claims require extraordinary naps. Or was it evidence? Either way, you're due for one. The fan in your room hums with cosmic precision, its gentle whir blending with the faint data tones you imagine from spacecraft telemetry. Numbers scrolling upward like lullabies, eccentricity, inclination, error margins. A particularly strange report arrives from the European Space Agency's Gaia mission. Its precise stellar measurements suggest that a faint gravitational perturbation ripples through local space, tiny, periodic, and roughly aligned with the galactic corridor traced by the interstellar objects. Could it be coincidence? Probably. Could it be something moving with them? Possibly. The term metastream starts circulating online. One researcher calls it the cosmic tide hypothesis. Another, less poetic, calls it the thing messing with my equations. Either way, the data is unanimous. Something unaccounted for is guiding the arrivals. You picture gravity itself leaning slightly to one side, as though accommodating an unseen guest. It's not the first time science has met its limits and smiled politely. The universe is full of polite laughter. When Newton's laws cracked under relativity, we adapted. When relativity met quantum mechanics, they shook hands and immediately started arguing. You suspect this will be the same. The next great theory might be germinating right now, somewhere between panic and wonder, waiting for the right insomniac to notice. For now, you simply float in the hum of unsolved math, feeling oddly safe amid the uncertainty. The models are breaking, yes, but maybe that's how the cosmos invites us deeper, one impossible orbit at a time. You hover now at the solar system's edge, where sunlight fades to a whisper and the outer planets march in slow, dignified procession. Beyond Neptune, the Kuiper belt lies like a scattered frost of rock and ice. It has always seemed so stable, until now. Something subtle is stirring out here. Faint gravitational tremors that make even the gas giants fidget. The solar system, normally indifferent to the passage of small interstellar pebbles, appears to be listening. At first, the effect seems laughably tiny. Millimeter-level discrepancies in the orbital positions of Neptune and Uranus, slightly off from what long-term ephemerids predict. It could be noise, data drift, telescope calibration. But the deviations aren't random. They repeat. Each oscillation matches the timing of the new interstellar arrivals. You feel that familiar shiver of curiosity, the kind that makes scientists forget lunch. A mainstream historical fact comes to mind. In the mid-1800s, those same planetary anomalies led Leverrier to predict Neptune's existence before anyone had seen it. The missing gravity betrayed the unseen planet's pull. You imagine him now, candlelight flickering across calculations, muttering about perturbations. He would have loved this. Only now the perturbation isn't from a planet. It's coming from outside, a rhythm echoing in from the dark. Deep space probes confirm it. Voyager 2, still dutifully transmitting from beyond the heliopause, registers tiny fluctuations in trajectory. New Horizons, coasting through the Kuiper belt, feels the same nudge, a consistent, almost musical deviation repeating every few weeks. Engineers blame software jitter, solar wind gusts, anything mundane. Yet when they plot the pattern, the timing aligns uncannily with each new interstellar object's entry. You lean closer to the imagined data feed and whisper, it's as if the solar system itself is tapping its foot. A quirky tidbit bubbles up. In 1977, the famous WOW signal was recorded by Ohio State's Big Ear radio telescope, a strong, narrow-band radio burst of unknown origin. It lasted 72 seconds, then vanished. Historians still argue whether it was a passing comet, a military satellite, or a genuine alien transmission. Tonight you can't help noticing the symmetry. Another strange signal, another rhythm, another unsolved pattern echoing across decades. The gravitational blips intensify slightly, not enough to disturb planetary orbits in any apocalyptic way, but enough to intrigue. Astronomers describe them as breathing. The entire outer solar system seems to inhale and exhale on a scale of weeks, as though responding to invisible tides. Some propose that clusters of interstellar dust, magnetized and massive, are sweeping past, tugging minutely at everything. Others suspect some resonant coupling between the sun's magnetic field and the approaching swarm. Either way, something unseen is tugging in time with the newcomers. The planetary scientists start sharing notes with heliophysicists, who normally keep to their own corner of the cosmos. The latter point out a curious synchronization. Fluctuations in the solar wind, streams of charged particles from the sun, now show periodic dips matching the same rhythm. Coincidence? Maybe. But the solar wind is our star's pulse, and it's suddenly syncopating with foreign visitors. One late night, an astrophysicist sketches a diagram on the back of an envelope, the sun at center, planets around it, and faint incoming trajectories forming a spiral. He draws tiny arrows along the spiral, representing the gravitational nudges measured by probes. When connected, the arrows form a waveform, up, down, it looks alive. He labels it jokingly, Solar System Response Curve. The name sticks. Historians still argue whether humour or wonder is the proper response to discovery. The two aren't mutually exclusive. In fact, they often arrive in the same breath. You smile at the image of scientists laughing softly while redrawing the map of reality. As weeks pass, the oscillations grow slightly more pronounced. Neptune's path wobbles just enough to make its future position uncertain by a few dozen kilometres, a cosmic hair's breadth, but enormous by astronomical standards. Predictive models strain to keep up. The joke, the solar system has the hiccups, becomes a conference meme. You picture the whole thing like a dance, the interstellar objects gliding in from afar, the planets shifting subtly in reply. It's call and response on a planetary scale, gravity as conversation. You wonder if in some deep mathematical sense this is how systems greet each other, through motion, resonance, rhythm. Maybe the sun hums back when the galaxy hums first. Another idea takes root. What if the visitors aren't causing the oscillations but revealing them, amplifying a pattern that was always there, like seeds tracing hidden currents in a river. Maybe the solar system has always been breathing. We just never had markers bright enough to notice the exhale. The thought comforts you. It turns the anomaly into a lullaby. A soft joke surfaces from a lab chat. If the planets start clapping in time, we'll publish. Everyone laughs. Yet deep down, they're watching for exactly that. Correlation tightening into choreography. The data so far suggests that as each new object passes perihelion, a subtle shift ripples outward. Like pebbles dropped in water, their wakes overlap, forming interference patterns. When the waves meet, the gravitational breathing strengthens. Your fan hums in your room, echoing that pulse. The air seems to thrum in sympathy. For a brief moment, you feel part of the system. A small, breathing object orbiting a small, breathing star, surrounded by larger bodies all nodding gently in time with distant visitors. Before you finally close your eyes, you think of one last historical echo. Johannes Kepler's old notion of music of the spheres, the idea that planetary motions create a kind of cosmic harmony. It was dismissed as mystical centuries ago. But tonight, with gravity humming in rhythm and your heartbeat sinking to unseen tides, you can't help wondering if Kepler wasn't wrong, just early. You slide back toward the inner system, through the soft glitter of reflected sunlight that gives even cold void a shimmer. The scientists who mapped those gravitational pulses are now staring at something else, an absence that feels louder than any noise. The radio telescopes, normally flooded with the comforting hiss of the universe, have fallen eerily quiet in certain bands. SETI arrays tuned to the frequencies where cosmic background, pulsars and human satellites mingle are finding gaps. Thin slices of silence carved right where static should live. They call it the radio silence. At first, no one notices. A few lost seconds of signal in a spectrum that stretches forever is like missing a grain of sand on a beach. But then it repeats. Identical gaps in data streams from facilities separated by continents. Green Bank, parks fast in China. Even the aging dishes at Arecibo's replacement node, scattered across the Caribbean, show the same pattern. The silence moves, a narrow notch migrating slowly through the frequency range as if sliding its finger across the dial. A mainstream historical fact rises from memory. In 1967, Jocelyn Bell Burnell first detected the rhythmic pulses of a radio source so precise that her team nicknamed it LGM1 for Little Green Men. It turned out to be the first pulsar, nature's own cosmic metronome. You smile at the symmetry. Once again, humanity finds order in the sky and jokes about aliens before rewriting physics textbooks. Maybe the silence is the new signal. In labs thick with the glow of monitors, engineers test every mundane explanation. Instrument drift, calibration error, local interference from passing satellites or military radar. They switch systems off one by one, and the silence persists. What unnerves them most isn't what they hear, but the fact that they don't hear it simultaneously from all directions. The gaps track the corridor of incoming interstellar bodies, aligning exactly with the region of the sky where 3I/ATLAS and its siblings are travelling. A quirky tidbit slides in from an older corner of science. In the early days of radio astronomy, scientists discovered that even the Milky Way itself emits a steady background noise. They called it galactic hiss. That faint, eternal murmur has been our constant companion for nearly a century, until now. Suddenly, along one narrow path through space, the hiss goes mute, like someone pressed pause on a section of the cosmos. The speculation spreads quietly at first, then like wildfire. Maybe dense plasma clouds are absorbing the radiation. Maybe the interstellar objects carry ionized dust that acts as a moving curtain, blocking certain wavelengths. One bold paper suggests something wilder, a form of interference, not absorption, but active cancellation, where electromagnetic waves meet their mirror twins and vanish. Historians still argue whether human science advances through cautious steps or sheer audacity. You suspect both. Meanwhile, SETI researchers can't resist testing the silence for structure. They record the precise timing of each gap and convert it to binary. The result produces a pattern, brief bursts alternating with longer pauses. When visualized, it resembles a heartbeat again, eerily echoing the gravitational breathing seen in the planets. The same rhythm translated from gravity to radio. You exhale slowly, feeling your pulse line up almost by instinct. The skeptics are quick to pounce. Correlation isn't causation. True, but the pattern is hauntingly tidy. Each beat coincides with the passage of another interstellar fragment through perihelion. It's as though the silence itself is synced to their arrival. You can't help thinking of it as punctuation, pauses between cosmic sentences. Someone at Greenbank overlays the radio gaps on a spectrogram of the sun's magnetic fluctuations. Perfect alignment. Even solar storms, chaotic by nature, seem to fall quiet for a heartbeat when the silence sweeps past. One astrophysicist writes in her notes, "It's like the universe is inhaling." The phrase sticks, whispered half in wonder, half in fear. There's humour too. There always is. A meme spreads online showing the universe holding a finger to its lips. Shh. Incoming message. You chuckle, because sometimes jokes are the only way to process awe. A quiet meeting unfolds at the SETI Institute. Lights dim to spare eyes already ruined by screens. The team reviews data from multiple observatories. The silence forms a moving arc, heading sunward. If extrapolated, it will cross Earth's orbit in a few months. No one says what they're all thinking. If it's natural, we'll measure it and move on. If it's not, well, that word still can't be said above a whisper. You picture the scientists staring into the hiss, headphones pressed tight, waiting for nothing and hearing everything. Maybe this is what contact looks like. Not a booming hello, but an intentional absence. A carved-out pocket of stillness saying listen differently. A mainstream echo returns. During Apollo 11's mission, when Neil Armstrong stepped onto the moon, Earth's radios went briefly silent between transmissions. That gap, just static replaced by nothing, made millions hold their breath. Sometimes silence is the loudest sound. Theoretical physicists join the fray, scribbling equations about standing waves and dark plasma. One suggests that the silence might be a side effect of gravitational resonance along the galactic corridor, a place where electromagnetic radiation cancels itself. Another speculates about phase inversion beacons, artifacts left by intelligent species who learn to speak through absence. You find that last idea strangely beautiful. After all, humans use pauses in speech for meaning too. Why shouldn't the cosmos? Outside, the night presses against your window. You can almost feel the hush spreading through the air, as if the universe's great radio dial has turned slightly toward mute. The fan in your room, once a steady companion, now seems too loud. You reach over, turn it down, and let the stillness thicken. Somewhere out there, the corridor hums with non-sound, an elegant emptiness flowing closer. You realize, with a sleepy grin, that you're doing what every scientist eventually does when faced with something incomprehensible, anthropomorphizing it, calling silence shy, giving voids intentions. But maybe that's how you bridge the gap between data and wonder, by giving mystery a heartbeat it might not need, but one you can recognize. Whatever the cause, physics, magnetism, or something far older, the radio silence rolls onward, synchronized with the incoming swarm. The universe, it seems, is speaking in the only language vast enough to hold everything at once, the quiet between stars. You find yourself moving through the hush that the silence left behind, a space where even imagination seems to echo. The instruments have gone still, but your mind keeps reaching backward, past data, past hypotheses, into the centuries when skywatching meant storytelling. Somewhere between the whisper of 3I/ATLAS and the static of your fan, you start remembering that we've been here before. Only we called it myth. The scientists compared notes, but the poets got there first. The Sumerian spoke of Anzu, the stormbird who stole the tablets of destiny from the gods and streaked across the heavens trailing fire. In medieval China, comet tails were said to be swords warning of dynastic change. You picture those ancient watchers standing where you are now, heads tilted, translating motion into omen. A mainstream historical fact reminds you that Halley's comet appeared in 1066 and was stitched into the Bayeux tapestry above the heads of kings. The thread still glows faintly under museum lights. Historians still argue whether that glow was reverence or warning, but either way it proves that people have always tried to write meaning into the night. Now you drift beside that long thread of time. The modern sensors hum below you, the old stories above, and in between something almost sacred stretches. Every civilization that ever looked up invented a reason for the lights to move. Maybe that was the first science, naming the patterns, finding cause inside coincidence. You can feel the same impulse curling in the present data. The orbital graphs from ATLAS look suspiciously like the spiral motifs etched on Neolithic stones in Ireland. The resemblance is probably nothing, but it makes you smile. Human pattern hunger is an ancient appetite. A quirky tidbit floats by. In 1910, when Halley's comet returned, newspapers reported that its tail contained cyanogen gas and that Earth would pass through it. Some entrepreneurs sold comet pills to neutralize the poison. Others hawked anti-comet umbrellas. No one died, except maybe from embarrassment. The episode reminds you that fear and wonder have always been the twin engines of sky lore. We invent danger when the cosmos refuses to give us clarity. You follow the thread further back. Greek philosophers imagined comets as celestial exhalations. In the Quran, they were signs guiding the faithful. The Maya recorded Venus cycles to mark the rhythm of war and peace. Now, in the glow of 21st century screens, we call them interstellar objects and measure isotopic ratios, but the feeling is the same. You're still that ancient watcher, squinting at movement in the dark and whispering, "What does it mean?" Historians still argue whether myth-preserved memory, whether old tales of sky visitors, could be garbled records of genuine events, close passes of comets, meteor storms, maybe even the long-ago appearance of a traveller like 3i/ATLAS. You like the idea that oral tradition might be a kind of data storage, messy but enduring. The ancients didn't have spreadsheets, so they wrote in poetry instead. One linguist notices something odd in global folklore databases. Stories from distant cultures, Inuit, Maori, Dogon, share imagery of stonefish that swim across the stars, shedding scales of fire. Could these be independent inventions, or echoes of some prehistoric comet whose fragments actually did rain down? The evidence is circumstantial, yet the coincidence hums in your bones. As you drift through these parallels, you realise that the radio silence we just heard feels strangely mythic too. Absence as omen. The ancients would have said a god held their breath. You wonder what future historians will say about our era. The people of the Silicon Age believed the stars went quiet to test their faith in algorithms. It sounds almost plausible. You float past libraries, both physical and digital, where dusty manuscripts describe fiery wheels, skyships, pillars of light. In them you sense the same longing that drives telescopes today. The wish to know whether we're alone. Perhaps every generation rediscovers that question, dresses it in the language of its tools. Where one age saw angels, another sees radio gaps. Both are attempts to name the shimmer between ignorance and awe. The fan in your room rattles once, breaking the reverie. You smile. Even machinery likes to remind you it's alive. The rhythmic hush returns, softer now, like the pulse of the interstellar highway receding. You picture those old storytellers looking over your shoulder, nodding as you translate data into bedtime myth. Maybe they'd approve. Before you drift off completely, one last historical echo tugs at you. In the Library of Alexandria, scholars once catalogued comets by colour: blood red, pale blue, serpent green, and debated whether they came from beyond the moon. The library burned and the records vanished, but their questions didn't. They're the same ones humming in every observatory tonight. Where did it come from? Why now? What pattern hides inside its passing? You breathe out slowly. The myth, the math, the silence, they all blend into one long human story. Maybe that's the real pattern forming around 3i/ATLAS. Not a geometric alignment of rocks, but a lineage of curiosity stretching from the first fires to the glow of your screen. You let the thought settle, warm and heavy, and the universe feels briefly personal, like an ancient friend leaning close to tell another story before sleep. The days pass and the hum returns, this time not from the fan in your room, but from the chatter of observatories, their networks lighting up like synapses. Something extraordinary is taking shape. The incoming objects, those quiet wanderers from interstellar space, are beginning to behave in a way no comet or asteroid ever should. Their orbits are synchronizing. One after another, they swing around the sun, not randomly, but in a cadence so precise it makes even the skeptics whisper. You drift through the virtual models, watching the patterns bloom like frost on glass. The perihelion points, their closest approaches to the sun, fall into alignment, tracing lines that intersect at regular angles. When connected, those lines form a faint hexagonal pattern, spiraling outward from the sun's center. You stare at it for a long time, torn between admiration and disbelief. Nature loves symmetry, yes, but not this kind. A mainstream historical fact steadies you. Saturn's North Pole famously hosts a hexagon too, a massive atmospheric vortex first photographed by Voyager in the 1980s, still spinning today. Scientists believe it's caused by standing wave patterns in the planet's atmosphere. Maybe, you think, the same principle could play out on a cosmic scale, gravity and momentum weaving their own invisible weather. Historians still argue whether the universe repeats itself at every scale, or merely rhymes when it feels poetic. Astronomers publish preliminary orbital plots, hesitant but intrigued. The alignments seem to follow a 60-degree symmetry, with each object's path positioned like a vertex on a slowly turning geometric flower. The resemblance to human-made design is uncanny enough to fuel every fringe theory imaginable. Forums overflow with diagrams, artists overlay sacred geometry, crop circles, even music notation. You chuckle softly. Give humanity a pattern, and we'll build a religion before breakfast. Still, the math refuses to dismiss it. The orbits really are clustering, their angular separations tighter than random chance allows. One researcher jokes that the solar system has joined a synchronized swimming team. Another compares it to orbital resonance, like Jupiter's moons locked into rhythmic motion. But these aren't moons bound to one planet. They're visitors from beyond the stars, coordinating like old friends arriving to the same dinner party from different cities. Telescopes in Chile, Hawaii, and the Canary Islands catch glimpses of faint tails glowing in unison, cometary plumes brightening and fading together as if choreographed. The timing defies coincidence. One theory proposes that the objects share a similar spin state. When they reach certain solar angles, their volatile materials heat and sublimate in sync. Another, more unsettling theory wonders if they're responding to something, perhaps a magnetic field, perhaps an external signal. You can't help imagining a cosmic metronome ticking somewhere in the background, inaudible but absolute. The solar system, still humming from those gravitational ripples, now feels like a stage preparing for choreography. A quirky tidbit bubbles up. Back in 2012, scientists studying quantum particles found that some systems self-synchronize, oscillating together without any external driver. They called it spontaneous order. If atoms can waltz in rhythm, maybe so can asteroids. The universe is full of mirrors, large and small. Public fascination grows. Amateur astronomers point their telescopes at the right patches of sky and start capturing time-lapse sequences, faint dots brightening one after another, their order repeating every few days. The footage goes viral. Someone edits the points of light to a synth soundtrack titled Dance of the Visitors. It racks up millions of views, proof that wonder still trends better than outrage, at least occasionally. You hover near one of the alignments, imagining the sun as the center of an enormous, slow-turning clock. Each object becomes a hand sweeping forward, marking intervals of cosmic time. It's mesmerizing, but unsettling too. The precision feels almost intentional. When the next interstellar traveler is spotted, designated 7I/Seraph, the pattern tightens even further, completing a nearly perfect geometric grid. Scientists can't decide whether to applaud or panic. Historians still argue whether great discoveries start with disbelief or with laughter. Here, both happen at once. One group insists it's an observational artifact, a quirk of perspective and timing. Another points to gravitational harmonics. Perhaps the swarm interacts through faint mutual pulls, shaping its own rhythm like dancers adjusting to one another. And then, of course, come the speculative papers hinting at possible engineered trajectories. The phrase alone sends half of academia into eye rolls and the other half into midnight Zoom calls. In your mind's eye, you replay the orbits again, tracing their luminous paths around the sun. For the first time, you notice something deeper. The alignments don't just form a hexagon, they precess slowly, turning like a mandala. Each rotation takes months, and at the end of each cycle, one fragment fades while another appears, replacing it perfectly. It's as if the pattern itself insists on continuity. You let your thoughts drift beyond reason for a moment. Suppose, just suppose, that the alignment is not accidental but functional, a structure built not of metal but of motion. Could a civilization have designed something so vast using gravity as its scaffolding? Maybe the pattern isn't a message. Maybe it's a mechanism, humming quietly through our corner of the galaxy. You breathe in, then out. The fan in your room spins a little slower, matching the imagined rhythm of those orbital petals. You feel the same drowsy awe that ancient watchers must have felt when constellations first took shape. Even if it's coincidence, even if the pattern collapses under better data, the sight itself is enough. When you finally let your eyes close, you picture the solar system as a glowing clock face turning gently in the dark, each visitor sweeping its path like a hand marking eternity. Somewhere out there, the universe is counting time in units far larger than ours, and for one brief lucid moment, you've glimpsed its geometry. You float through the invisible lattice that those synchronized orbits have drawn across the solar system, following the faint trail of magnetism they leave behind. The telescopes can't see it directly, but the instruments can feel it, the way compass needles quiver when a storm rolls in. Everywhere the fragments of 3I/ATLAS and its kin pass. Magnetometers twitch as though something is whispering in frequencies just below comprehension. They call it the magnetic murmurs. At first, the readings seem trivial, variations measured in nanoteslers, nothing that should mean anything on the scale of planets. But as more spacecraft and probes detect the same pattern, a pulse emerges. The fluctuations aren't random. They oscillate, faint but rhythmic, rising and falling with uncanny regularity. You picture the void breathing again, but this time the breath is electromagnetic. A mainstream historical fact comes drifting through. In 1979, Voyager 1 passed Jupiter and detected radio emissions produced by the planet's intense magnetic field interacting with its moons. The discovery birthed an entirely new field, magnetospheric physics. It proved that magnetism in space isn't static, it sings. Maybe what you're hearing now is a much older song, played on instruments scattered across light years. The data plots fill with fine, sawtooth waves. At every perihelion pass, as each interstellar body swings near the sun, the signal sharpens, like a string pulled taut. It's too coordinated to be noise, too faint to be obvious intention. Scientists compare notes. Some call it a resonance effect. Metallic minerals inside the objects heating, cooling, and generating tiny magnetic fields as they tumble. Others wonder if these murmurs are a byproduct of their motion through the sun's magnetic sheath, a cosmic bow scraping across the violin of the heliosphere. Historians still argue whether science first advances through the ears or the eyes, whether we notice a phenomenon because we see its trace, or because we hear its rhythm. Tonight, you suspect both senses are finally working together. A quirky tidbit rises from memory. In the 19th century, telegraph operators reported hearing faint music through their wires during solar storms, what they called singing lines. Later we learned it was electromagnetic interference, but at the time, people swore the heavens themselves were playing melodies. You wonder what they would think if they knew that a century later, spacecraft are hearing the same song across billions of kilometers. As you drift among the virtual readouts, you imagine each object as an instrument in an enormous orchestra, some humming in bass tones, others chiming in treble whispers. The combined waveform forms a pattern that looks almost scripted. 6 peaks, 1 pause, then 6 again. Mathematicians notice that the ratio echoes the geometry of the swarm's hexagonal alignment. Coincidence or design? No one knows. In a lab somewhere, a graduate student overlays the magnetic data onto the radio silence pattern from earlier sections of the sky. The match is eerie. The silence and the murmur are two halves of the same wave, as though the universe alternates between holding its breath and exhaling through magnetism. Someone jokes that the cosmos has discovered ASMR. Everyone laughs, but softly, as if afraid to interrupt the hum. You picture a deep space probe sailing through the region where the murmurs are strongest. Its sensors register oscillations not just in magnetism, but in plasma density, forming concentric rings of disturbance that expand outward like ripples from an invisible drop. Engineers had predicted mild turbulence. Instead, they find order, waves nested within waves, their spacing identical to the gaps between the interstellar objects. Back on Earth, the data converts easily into audio because humans can't resist turning numbers into sound. When compressed into seconds, the murmur becomes a low, rising chord, half wind, half heartbeat. You listen, eyes closed. The tone is soothing and slightly eerie, a lullaby sung by something vast. The internet names it the song of a TLAS. Musicians remix it. Sound designers claim it relaxes pets. You smile. Humanity always finds a way to turn the incomprehensible into background noise. Meanwhile, theoretical physicists attempt to decode it properly. Could these fluctuations indicate rotating magnetic dipoles, metallic cores, or something even stranger, oscillating plasma loops intentionally stabilized? The last theory gets side-eyed at conferences but whispered about afterward. The murmurs are too structured, too consistent across different objects to ignore completely. Someone remembers the pioneer plaques, the golden diagrams we sent on our own spacecraft, using simple geometry to say we were here. Maybe, one whispers, the murmurs are their equivalent. Physics as language. Magnetism is universal. Any civilization that builds technology would understand it. But the notion feels both profound and absurd. Could intention survive across millions of years of drift? You drift alongside those thought experiments, letting them unfold like dreams. Maybe the murmurs aren't messages at all, just natural feedback between gravity, motion, and magnetism. Or maybe that's precisely the point. A universal medium, meaning encoded in structure rather than syntax. You realize how small you are, how fortunate listening to phenomena no ear was designed to catch. Your own surroundings hum in sympathetic vibration. The faint buzz of electronics, the steady rotation of the fan, they merge with the imagined cosmic chord until you can't tell which sound belongs to you and which to the galaxy. For a moment, you're both observer and participant, tuned to the same invisible key. When you finally pull back, the murmurs continue, unbothered by human curiosity. They weave through the orbits, twining magnetism and motion into a single, slow rhythm. The data logs label it background variation, but you know better. It's the universe clearing its throat before the next verse. The murmurs have become a permanent undercurrent, steady magnetic breathing that hums through the data feeds and settles behind the eyes of everyone listening. You can almost feel it vibrating the desk under your elbow, though you know it's just imagination translating distance into touch. Across the world, the conversation about what these rhythms mean has gone from quiet speculation to open argument. The community is splitting into camps, the air between them thick with coffee, conviction, and thinly veiled awe. At the International Astronomical Union's Emergency Symposium, the main hall fills with exhausted researchers and opportunistic reporters. You drift through the digital replay, invisible and comfortable. One presenter stands at the podium, hair a halo of static pointing to a holographic display where the interstellar objects' paths glow in soft blues and golds. It's natural, she insists. A galactic filament intersecting the solar system, magnetic turbulence shaping debris. Beautiful, yes, but not deliberate. Half the room nods, the other half is already composing rebuttals. A younger scientist, eyes red from lack of sleep, interrupts politely. If it's turbulence, why does it repeat? Why are the orbital ratios exact multiples of each other? His voice cracks halfway through, exact. There's a ripple of laughter, not ridicule, just nervous energy released into the room. A mainstream historical fact drifts in. At the end of the 19th century, Lord Kelvin declared that physics was complete, that only a few decimal points remained to be refined. Within 2 decades, quantum mechanics and relativity had demolished that certainty. Historians still argue whether confidence is the seed of progress or the prelude to humility. Watching these modern scientists, you suspect it's both. The moderator calls for order. New slides appear, magnetic field maps, resonance curves, snippets of the now famous Song of ATLAS. The data flickers like a pulse on a medical monitor. Another presenter takes the stage, arguing that the synchrony hints at galactic filament harmonics, essentially space weather on scales we've never modelled. He calls it the cosmic violin effect. No intelligence required, he concludes, smiling as though he's ended the story. A woman in the back raises her hand. Her badge identifies her as a historian of science, which means she's both welcome and mildly resented. "Forgive me," she says softly, "but we've said no intelligence required at every great threshold in history, until we realised intelligence might take forms we weren't ready to recognise." The hall goes quiet, the kind of silence that hovers just before applause or panic. You drift closer, sensing the tension sharpen. The phrase, "a deliberate design," finally enters the transcript. Immediately objections bloom. Impossible. Extraordinary claims. anthropocentrism. Yet the very resistance betrays fascination. One researcher pulls up a 3D model showing that the object's spin axes, though randomly oriented in theory, cluster along two opposing directions, like magnets aligning to a distant pole. It could be coincidence. It could also be choreography. In another corner of the hall, smaller groups break into whispered debates. Some talk about galactic filaments, webs of plasma stretching between stars that could shepherd material across vast distances. Others trade rumours of a deeper pattern, the rhythmic arrival times forming a logarithmic series, the kind that suggest exponential timing, like someone scheduling deliveries. The phrase galactic metronome trends online before the session even ends. A quirky tidbit slips into your reverie. In 1928, the artist Alexander Calder invented the mobile. Sculptures balanced so precisely they moved with air currents, their motion dictated by harmony rather than force. Looking at the model of orbits suspended around the Sun, you think Calder would have approved. The solar system has become his gallery piece, turning slowly, every motion interconnected. Outside the conference, the world joins the argument. Talk shows joke about space drones. Governments issue cautious press statements affirming that no threat has been detected. The public predictably skips straight to memes, hexagonal logos, I joined the Galactic Swarm t-shirts, playlists claiming to replicate the magnetic murmurs. Even skepticism becomes participatory art. Inside academia, the schism deepens. The naturalists insist that the pattern is emergent order, no more mysterious than the stripes on a zebra. The designers, they hate the nickname but it sticks, argue that emergent order can itself be intentional, that perhaps intelligence once nudged the process and then let physics handle the rest. You can almost see history looping, Copernicus versus orthodoxy, Darwin versus doctrine, always the same melody of discomfort resolving into progress. Historians still argue whether paradigm shifts happen gently or by revolution. Judging from this crowd, you'd bet on polite chaos. Late in the night, after the conference adjourns, a smaller team gathers in a darkened control room. They've superimposed all the data, gravitational magnetic radio, and found a new coincidence. The oscillations align in phase only when mapped relative to the galactic center, not the Sun. It's as if the rhythm doesn't belong to our neighborhood at all, but to something larger, something that spans light years. Someone whispers, "We've been thinking heliocentric again." You can almost hear Copernicus chuckling in the background. Another scientist traces the waveform on the screen with her finger. "If it's real," she murmurs, "it means the pattern started long before our Sun existed." The words hang there, heavy as starlight. No one answers. You retreat from the glow of monitors, carrying that thought with you. Maybe the debate doesn't need resolution yet. Maybe the argument is the experiment, the way humanity tests the limits of wonder. The naturalists and the designers, both right in their own way, are simply describing different dialects of awe. Outside your window, the night feels charged. Even the city's neon seems to flicker in time with the unseen rhythm threading through the galaxy. You close your eyes, letting the arguments dissolve into a steady pulse. Whatever the truth turns out to be, filament, mechanism, or memory, the conversation itself is proof that the universe still knows how to surprise us. You open your eyes to a strange comfort, the sense that all those debates and murmurs have settled into something calmer, steadier, like a pulse finally finding its beat. The data no longer looks random, it breathes. Somewhere between the gravitational rhythms, the magnetic whispers, and the radio silence, a deeper pattern has emerged. Astronomers, statisticians, even musicians start seeing it independently. It's a timing pulse, faint but regular, ticking through the arrival of every new interstellar object. They call it the hidden rhythm. It starts with one obsessive postdoc in Chile who aligns the arrival dates of 1I/Oumuamua, 2I/Borisov, and 3I/ATLAS, then extends the sequence to include the newer fragments. When plotted logarithmically, the spacing between their discoveries falls into a near-perfect curve, a slow exponential acceleration, each visitor arriving just a little sooner than the last. Not random, not evenly spaced, something in between, like a heartbeat quickening with purpose. A mainstream historical fact steadies you again. In 1967, Jocelyn Bell Burnell's first pulsar discovery also began as timing irregularities, ticks on a chart that were too consistent to be noise, They called it LGM1 before they knew it was a neutron star. Historians still argue whether the joke helped or hindered her recognition, but one thing is certain: rhythm in data is rarely coincidence. Soon, observatories worldwide confirm the pulse. The arrivals aren't just random stones slingshotting from alien systems, they obey an invisible tempo. The intervals shorten by about 3.7% each time, a tiny fraction but statistically unignorable. Models that once drifted apart now snap together, their predictions eerily matching the next discoveries. The cosmos has turned into a metronome ticking across decades. You float among the models, watching numbers turn into music. Someone at MIT runs the intervals through an audio converter and speeds them up until a tone emerges, a simple, pulsing hum. It sits between B-flat and A, low enough to feel rather than hear. They play it at the conference, half as a joke, and the audience goes silent. The sound feels alive. A quirky tidbit arrives. In 1619, Kepler published Harmonices Mundi, claiming that planetary motions followed musical ratios, the literal music of the spheres. His contemporaries laughed, but his intuition about harmony and motion wasn't wrong. He saw resonance where others saw chaos. You wonder if the same thing is happening again, if this hidden rhythm is the modern echo of that ancient dream. As more data piles up, the rhythm reveals finer structure. The arrival intervals form groups of 7, then pause, then repeat. Within each group, the pattern accelerates, as if something invisible is breathing through the sequence. A mathematician points out that the ratio resembles the Fibonacci spiral, the same sequence that governs shells, hurricanes, galaxies. Maybe, she says softly, this is just how the universe keeps time. Not everyone is so romantic. Skeptics insist that human detection bias is creating the illusion. We only find what we're ready to look for, they argue. Maybe we're just getting better at spotting faint objects. The acceleration could be technological, not cosmic. Historians still argue whether better instruments create discoveries or simply reveal what was already there. Either way, the rhythm persists. A team in Japan notices something else. Each object's approach vector, its angle of entry relative to the galactic plane, shifts incrementally, as though each were part of a slow spiral, drawing closer to the sun's orbital path around the galaxy. It's not enough to change planetary safety, but enough to be noticed. The pulse isn't only in time, it's in space. The newcomers are arriving like dancers stepping down a staircase, each in sync with the last. You imagine standing at a cosmic balcony watching that choreography unfold, one by one, glowing specks sweeping inward. The pulse is slow, elegant, vast. For a moment you feel the smallest sense of anticipation. If the rhythm continues, the next arrival should appear sooner than expected. Months, maybe weeks. Observatories prepare. Search algorithms run non-stop, scanning the dark for the next beat of the cosmic drum. The night before the predicted date, every telescope capable of catching faint motion points toward the inbound corridor. Nothing at first. Then, a faint flash. A small, elongated object enters the system from precisely the expected region, precisely the expected angle. 8I/Peregrine. The crowd in the control room cheers, half in triumph, half in disbelief. Probability bows its head. It's official, the pattern can predict the future. The media explodes, calling it the universe's heartbeat. The phrase sticks, and within days, everyone from physicists to poets is using it. Some even calculate that, extrapolated backward, the rhythm would have begun millions of years before our sun existed, pulsing quietly through the galaxy like a biological signal in deep time. The implication sits heavy in the air. If this is natural, it's the most precise natural rhythm we've ever seen. If it isn't, if it's deliberate, then something out there has been keeping time for longer than life has existed on Earth. You lean back, eyes closed, feeling your own pulse echo in your wrist. It aligns, absurdly, with the rhythm on screen. Thump, thump, thump. A joke, maybe, but a soothing one. The fan hums its quiet harmony. The notion of the hidden rhythm stops being terrifying and becomes strangely intimate, like the galaxy is breathing beside you, sharing its secret cadence. Before you drift off, you remember an old line from Carl Sagan. We are a way for the cosmos to know itself. Maybe this rhythm is another way, an awareness older and broader, playing itself across time. Whether natural or not, you realise the effect is the same. The universe is humming, and somehow you've learned the tune. The night you first hear of it, you're already half asleep. The data feed scrolls lazily across your screen, the numbers soft as rainfall when the alert comes in. Deep Sky Survey detects anomalous object. Slow, massive, inbound. You blink at the timestamp. It fits the rhythm perfectly. The next beat, the next verse. Except this one is different. Bigger, slower, as if the melody has dropped an octave. Astronomers name it, for now, 9I/Aeon. You pull back through the swirl of orbits that have defined the last months. The smaller visitors look like sparks thrown from a forge. This new one is the ember that follows. Its trajectory curls through the same corridor but carries more weight. Its light curve suggests something large, tens of kilometers across. The Discovery teams whisper that they might be looking at the origin of the pattern, the core object. A mainstream historical fact slips in for scale. In 1994, fragments of comet Shoemaker-Levy 9 slammed into Jupiter, each one leaving a dark scar wider than Earth. Those impacts taught us how gravity can rip a single body into a chain of fragments. Historians still argue whether that event was a cosmic accident or a preview of the delicate violence that shapes planetary systems. You glance again at Aeon's slow path and think, maybe 3I/ATL-AS, and its kin were once part of something whole. Telescopes pivot toward the newcomer. It reflects little light, darker than charcoal, but radar pings return strong, too strong for a fluffy comet core. The density hints at metal mixed with stone, a composition closer to an asteroid than ice. Yet faint gas jets bloom from its surface, releasing clouds of complex molecules that shimmer in infrared. A contradiction: comet behaviour, asteroid mass. The universe's favourite joke. Spectrometers pick up oddities. The reflective spectra show spikes at unusual intervals, lines no known element should produce. One researcher mutters, "It's like someone added punctuation to a sentence written in atoms." Another notices that the spacing between those spectral lines matches the timing pulse discovered earlier. The hidden rhythm is encoded even here, humming through chemistry. A quirky tidbit floats from the archives. In 1972, the Soviet space probe Venera 8 transmitted back a rhythmic beeping from Venus's surface, 3 short, 1 long, before falling silent. The engineers swore it was only telemetry, but conspiracy buffs turned it into Morse code. You smile at the parallel. Every time the universe taps a rhythm, we can't resist calling it language. As Aeon approaches, its gravitational wake begins to tug faintly on its smaller siblings, tightening their choreography. The entire swarm seems to pivot around it like dancers around a lead. The models update hourly, and a slow realization settles across the community. The swarm isn't random debris after all. It's an entourage. Aeon isn't following the others were heralds, scouts preceding it by centuries. You hover in the visualization. The trajectories of Oumuamua, Borisov are TLAS, and the rest converge if traced backward. They meet near a single point far beyond the galactic arm, as though once clustered around a parent body. The timing pulse, the alignments, the murmurs, all of it now seems to radiate from that same source. Scientists begin to whisper the word progenitor. The debate flares up again. The naturalists say Aeon is the shattered core of a rogue planet, gravity's orphan, spinning alone for eons until the galactic tide nudged it here. The designers counter that its coherence is too deliberate, its orbit too precisely tuned to the ongoing sequence. Historians still argue whether civilization can leave fingerprints on time itself, but tonight, you can almost see them glowing. Infrared imagery sharpens as Aeon crosses Neptune's orbit. Its surface gleams in patches, not randomly, but in patterns, hexagonal tiles alternating bright and dark. Some claim it's geology, crystalline layering from ancient pressure. Others notice that the geometry mirrors the swarm's orbital alignment. The resemblance is hard to dismiss. The first spectra of its emissions bring another surprise, a narrowband radio echo repeating every 11 minutes. It's too regular for noise, but too faint for communication. Observatories verify it across multiple instruments. Even the skeptical teams confirm. The echo persists, modulating subtly in sync with the hidden rhythm. Whatever Aeon is, it's participating. You imagine standing on some lonely ridge of Pluto, watching this slow giant slide across the background stars. It's not bright enough for the naked eye, yet you'd swear you could feel it. A pressure in the air, a tension in your chest, as though the solar wind itself is aware of the arrival. A mission proposal forms almost instantly. A rapid probe using gravity assists from Jupiter to intercept Aeon before it departs. Engineers dust off designs from past comet missions, Rosetta, Hayabusa, OSIR, ISR, EX, and start merging them into something new. It's just another rock, one director says, but no one believes that. Funding floods in anyway. Meanwhile, social media names it the core object. Documentaries update their graphics overnight. Musicians remix the radio echo into ambient tracks. Conspiracy theorists declare it a cosmic arc, or a god returning, or a galactic beacon finally reaching its destination. The rest of the world simply stares upward a little more often, reminded that the sky is moving. You drift back into your own thoughts. If Aeon truly is the origin, then the pattern we've been tracing might be a message written in trajectories, motion as syntax, gravity as grammar. Maybe this is how a civilization that outlived its own language still speaks. Or maybe it's nothing more than physics humming to itself, self-similar across eternity. Either way, you feel small and privileged to be alive for the crescendo. As Aeon nears Saturn's orbit, the radio echo shifts once more, just slightly, just enough for algorithms to notice. The pulses form a repeating triplet, long, short, short. Musicians hear a waltz. Physicists hear data compression. You hear a heartbeat. You lean back, eyes half closed, imagining the solar system as a vast concert hall where each world vibrates in sympathetic resonance. The newcomers have been tuning the strings for years. Now, at last, the conductor is arriving. You ride the rising hush into motion, the way you stand up from a dark theatre seat when the house lights lift and the orchestra hasn't quite stopped vibrating. The alert about 9I/Aeon has barely cooled before the plan accelerates past caution into choreography. You're in the room, virtually but close enough, as mission teams sketch trajectories on whiteboards, their markers squeaking in little parabolas. "We can make it," someone says, and you feel the collective inhale as the entire building commits to crossing the threshold from watching to touching. They name the interceptor in a late-night vote that feels like a sleepover dare, Threshold. Someone suggests breadcrumb, and a tired engineer writes it on a sticky note and slaps it to the coffee machine anyway. The architecture is a mashup of everything that's ever worked. Solar electric propulsion for long, patient pushes, a chemical kick for the last-minute pounce, a magnetometer wand, a radar tomograph, a bouquet of tiny penetrators dubbed pebbles because humour prevents panic. A sampler lives in the belly. If Aeon sheds crumbs, you'll eat politely and ask for more. You watch the simulations spool out like dream threads. It's a threading the needle thing, a Venus gravity assist, then a Jupiter slingshot that tilts the plane just enough to sneak into Aeon's path. Launch windows become sacred. Every hour's delay now means days later. Your brain does that anxious phone battery thing at 2% for the entire solar system. A mainstream historical fact floats in and steadies your nerves. In 2014, ESA's Rosetta mission delivered the Philae lander to Comet 67P/Churyumov-Gerasimenko- the first ever soft touchdown on a comet. The harpoons failed, Philae bounced twice, then napped dramatically in a shadow, but science still poured out. We've kissed ancient ice before, we can do it again. Historians still argue whether Philae's bouncy landing was a fiasco or a masterclass in improvisation. You decide both can be true, like most good stories and all good naps. Teams practice approach choreography. Sunward isn't an option. The glare will roast instruments and blind guidance. Instead, Threshold plans a dogleg in Aeon's cold-lit shadow, surfing the magnetic murmurs like a blindfolded surfer listening to the wave. Your inner skeptic coughs. Your inner dreamer is already humming the Song of Atlas in the key of maybe. There's a quirky tidbit on the wall of the control room. A little 3D printed Juno minifigure, yes, Lego, bolted to a console. Juno actually flew 3 special minifigs to Jupiter. Engineers love smuggling whimsy across the void. Taped beside it is a printout of the radio silence notch, annotated with a heart. The juxtaposition makes you grin. Humans throw toys at gods and call it engineering, and somehow the gods answer with data. Launch night arrives quiet, crisp, and unreal. The rocket flexes against gravity, then shrugs it off. The fairing splits like eyelids opening. The upper stage yawns and pushes. Threshold separates with the gentle arrogance of anything that knows it's about to make history and also needs a nap. Ground stations catch the first handshake. You imagine the relief in that single tone, the beep that says, "I'm here, and please turn me the right way up." Cruise is a ribbon of patience. The plasma thrusters hiss faintly, each xenon atom leaving like a tiny sigh that adds up to an interplanetary shove. Every course correction is a coffee sip in mission control. The team starts anthropomorphizing both spacecraft and target in the way you promised yourself you wouldn't, and then did anyway. It's fine. You anthropomorphized your coffee maker, remember? As Threshold climbs the curve toward Jupiter, you practice a different kind of listening. Magnetometers on interplanetary probes passively eavesdrop, mapping the corridor's murmurs in higher fidelity than any flyby dared before. The wave's spine becomes visible, nested shells of plasma density and magnetic twist, aligned not to the sun, but, still weirdly, to the galactic center. Copernicus clears his throat in your peripheral vision. You nod. Jupiter flashes by, a gravity god in full regalia. The slingshot swings Threshold into a lane only the math can see. Past Saturn's realm, the radio echo from Aeon deepens slightly, long, short, short, like a waltz whispered through iron. The radar team, eyes rimmed in insomnia, smiles without moving their faces. You can hear their thoughts. If it's a rock, it's the strangest rock. If it's not, brace. Approach day unfurls in 20-hour minutes. Aeon fills the optical frame not by shining brighter, but by erasing stars. Its dark albedo a chalk outline on night. Thermal maps bloom, alternating hexagonal patches warmer, cooler, like a tiled skin conducting heat on purpose. The pattern's orientation precesses in lockstep with the swarm's hexagonal alignments you watched earlier. Someone whispers, "Oh!" No one tells them to elaborate. Range, 5,000 kilometers. The radio notch thickens across bands, solar wind density dips. Plasma waves line up like ridges in a vinyl record. Guidance switches to limb tracking. LIDAR strobes whisper against a silhouette as crisp as engineering diagrams dare to be. You coast in the quiet between pulses, letting Aeon's waltz set the tempo. It's a ridiculous thing to do. It works. At 1,000 kilometers, radar tomographic sweeps begin. The returns write a story in strata. Outer regolith. Sure, but underneath densities shift in repeating intervals. Voids that look suspiciously like cavities, some with angles behaving like right ones when nature usually prefers curves. A seam, no, a boundary, runs through the scan, separating two domains with different dielectric signatures. The mission lid says the word interface, and then stares at the table as if the grain might blink back. Your brain reaches for anesthetic humour. If there's a space TSA, now is the time, you murmur to yourself, remembering your earlier joke about 3I/ATLAS declaring snacks. You picture Aeon submitting a tray of hex tiles and mysterious cavities for inspection, while we pat down the void for contraband physics. You chuckle softly. The tension notices and recedes a hair's breadth. The pebbles, those tiny penetrators, arm themselves with unreasonable optimism. Their job is simple in the way tightrope walking is simple. Impact at a few hundred meters per second, sniff the ejector, transmit before expiration. You watch as four depart, streaking silently, starlight glancing off their skins like a blessing. 3 vanish into darkness. 1 skips and spins off, flashing intermittently like a loose thought. Data arrives anyway, molecules you expect, water, carbon monoxide, and molecules you don't, complex polymers with repeating units that look engineered. If you squint, and you are definitely squinting. Historians still argue whether the Viking landers in 1976 found life on Mars. One instrument said, maybe. Chemistry said, probably not. Here too, ambiguity is the flavour of the century. The polymers could be long-chain tholins sculpted by time. The cavities could be nature's pareidolia. The heat tiles could be fractures imitating order. You whisper the mantra, extraordinary claims, extraordinary evidence, extraordinarily sleepy brain, hydrate. Threshold dives to 250 kilometers for the kiss, a hover that isn't quite a hover, a mutual falling arranged to cancel itself. Close enough for high-res imaging. The surface resolves, ridges braided like ropes, pits tessellated into hexes that aren't purely geometric but are undeniably regular. Fine dust gusts in pulses matched to the 11-minute radio echo, as if the ground sighs on a schedule. A bright scarp glints, and beneath it something stratified gleams like metal if metal learned to grow. 2 jokes sneak through your lips because you have to. 1, we should slather on that ancient crocodile dung sunscreen. We're getting roasted here. A callback that earns a ghost of a smile even from your own reflection. 2, a mutter about adding Aeon to your grocery list because it seems to be composed of nope with traces of huh. Then the thing that changes the room happens. As threshold slides across the night side, the magnetometer chirps and the radio notch inverts, a momentary unsilence, and a lattice of faint, coherent radio at a single drifting frequency spills out like breath fog in winter. Not speech, not code, a carrier. It lasts 37 seconds. Enough to record, to triangulate, to whisper the word active and then say, or we just flew through a plasma caustic, because sanity demands an alibi. Back us out, the flight director says, voice wrapped in velvet. Threshold obeys, drifting to a safe station 800 kilometers away. The swarm, those earlier heralds, glitter faintly in the distance, their tails braided by fields you feel more than see. Aeon turns slowly, as if to show its quiet face, and the 11-minute waltz resumes, unbothered. In the debrief, everyone remembers different details, the hexes, the cavities, the moment the silence became a breath. No one says ship, no one says artifact. The official words are structure-like, resonant, non-equilibrium. You swallow those adjectives like calming tea. They go down warm. The room agrees to the only plan that makes sense when the universe blinks first. Return tomorrow, closer, slower, kinder. You lean back from the screen, noticing your own heartbeat syncing with the 11-minute metronome in your head. Crossing the threshold was never going to answer everything. It wasn't supposed to. It was meant to change the kinds of questions you're allowed to ask. Out the window, the night is ordinary again. Streetlights, a cat, a distant siren pretending it's a comet. Inside, you're anything but ordinary. You have stood on the lip of someone else's long, patient motion and felt it breathe. You have called rock and been answered by rhythm. You have one more sleep before the next approach, and you take it like a promise. The second approach begins in silence. It's the kind that feels deliberate, a held breath before a final note. Threshold drifts along its calculated arc toward Aeon, gliding through that same corridor of magnetic hush. The spacecraft's instruments hum softly, each sensor primed to catch whatever whisper comes next. You can almost sense the collective heartbeat of everyone back on Earth. Technicians, scientists, the insomniacs watching live streams, all synchronized with the probe's steady pulse. The plan is simple: closer pass, slower descent, no touching. The world doesn't need another bounce like Phileas, it needs patience. You hover mentally beside Threshold as it closes the distance, its ion engines flicking pale blue light into the dark. Ahead, Aeon looms, vast and calm, its tiled surface glinting faintly like cooled metal under moonlight. A mainstream historical fact surfaces to remind you how fragile this moment is. In 1969, Apollo 11's descent nearly failed when the onboard computer overloaded with alarms. Neil Armstrong had to take manual control in the last seconds. Historians still argue whether courage or luck landed humanity that day. Here, courage and luck ride together again, only this time there's no human hand on the controls. Threshold's cameras open their shutters. The first close images reveal that the hexagonal tiles aren't perfectly uniform. Some are raised, others recessed, and within their seams run lines that shine like liquid mercury. They twist and braid, forming patterns that recall circuitry or veins, functional beauty hidden under eons of dust. Every pulse of the 11-minute radio rhythm ripples faint light through those seams, as if the entire surface were breathing photons. You whisper to yourself, the pattern breathes. Mission Control catches its breath too. Sensors pick up a localized magnetic surge, stronger than any comet or asteroid should emit. It oscillates at a frequency exactly matching the hidden rhythm, and this time, it's not passive. The wave intensifies as Threshold approaches, then stabilizes, holding a steady tone like a tuning fork struck by the universe. a quirky tidbit surfaces from the archives of forgotten technology. In 1890, Nikola Tesla claimed he could feel vibrations through the ground, a resonance that shook his laboratory. People laughed until the science of seismology proved that Earth itself has natural modes of vibration. Maybe Aeon does too. Maybe all worlds hum when listened to closely enough. Data streams flood in, density scans, temperature maps, plasma readings. The interior voids detected earlier now resonate faintly in harmony with the surface rhythm. It's as if Aeon's entire body is a single instrument tuned across dimensions of matter and magnetism. Engineers call the phenomenon global coherence. Philosophers call it too poetic to publish. Historians still argue whether the difference between art and science is just vocabulary. Tonight, the debate feels moot. The boundary has dissolved into music. The probe dips lower, 200 kilometers above the surface. A new echo joins the chorus, a delayed reflection of Threshold's own radar pings, distorted, returned not as noise but as mirrored data packets. Decoding teams scramble. The packets aren't random. They're rearranged versions of the signal we sent, compressed and resequenced into symmetrical strings. It's reflecting, one analyst breathes. Not mechanically, intentionally. No one says the word reply, but everyone thinks it. You imagine Aeon not as a ship, not even as technology, but as memory solidified, an ancient machine that once served a purpose so large it no longer needs to move. Perhaps it records, or regulates, or dreams. The smaller interstellar objects were its fragments, released deliberately or by decay, carrying echoes of its pattern through space. Each arrival was a heartbeat, each orbit an echo of the original design. Threshold circles once more, and for the first time you see Aeon's shadow ripple. Not metaphorically, the shadow moves, expanding and contracting as if the object itself flexes in response to sunlight. Spectrometers spike. Bursts of infrared heat radiate along its hex lines, blooming outward like petals of a mechanical flower. The radio silence that once haunted the galaxy fractures into layered harmonics, is no longer mute, it's singing back. The tone builds, a sound below hearing, felt in data streams and bones alike. Instruments record a complex frequency lattice, harmonics nested within harmonics. Analysts begin to notice patterns encoded in phase shifts, prime numbers, Fibonacci intervals, and ratios that correspond eerily to the orbital geometries of the swarm. The message, if that's what it is, feels less like words and more like mathematics folded into rhythm. Existence expressed as a pattern of balance and breath. Back on Earth, people gather in plazas and living rooms to watch the transmission feeds. No one can hear the real frequencies, but the data has been translated into audible sound. A deep, pulsing choir that seems to throb inside the chest more than through the ears. Some cry, some laugh, some simply close their eyes. The universe has chosen lullaby as its dialect. You think of every ancient myth that spoke of singing stars and music in the heavens. You think of Kepler's music of the spheres, of Bell Burnell's pulsars, of the murmuring dust trails and magnetic whispers that led here. The pattern was never random. It was recursive, self-aware, alive in its own quiet way. Maybe Aeon isn't a messenger. Maybe it's a metronome, reminding the galaxy to stay in time. As the tone peaks, threshold sensors overload briefly. Images smear into streaks of light, telemetry trembles, then the signal steadies. Aeon dims again, settling back into silence as though satisfied that someone finally listened. The radio echo fades to its familiar 3-beat waltz. Mission control erupts in cautious applause, the sound of disbelief mingled with reverence. The probe drifts upward, its trajectory carrying it safely away. It leaves behind no flag, no footprint, just data, song, and a new humility. The solar system returns to its steady rhythms, but you know it's not the same. Somewhere in that silence now lives a wordless conversation between starlight and curiosity. You exhale, and for a fleeting moment, the hum of your fan syncs perfectly with the galaxy's rhythm. You imagine Aeon still pulsing out there beyond Saturn, its pattern breathing slowly, eternally, as if the universe itself were asleep but dreaming vividly. The story has circled back to stillness, but nothing is truly still. Not light, not dust, not you. The pattern continues, alive, infinite, and listening.